Stefan to kick off the workshop. So Stefan, it's all yours.
Thank you, Emad. So, hi and welcome everybody to the second international workshop on bots and software engineering, short BotSE. It's the second iteration, but it feels like the first one all over again because this is totally new, of course, for all of us. If you're like me, you probably have attended some of the workshops or other co-located events of ICSE in the last couple of days. And I think we've seen a lot of interesting discussions nevertheless, and I guess we also have some opportunities that we maybe would not have had in Seoul, that maybe not everybody could have attended. So we try to make the best of what we have, and we'll see how it goes. Next. So who's BotSE? These are the organizers. So in the top row, Marco, Emad and me, we are the main organizers, but we had quite a lot of support from the guys there, Ahmad, Marvin, Khalid, and Glaucia, who had different roles on the website, in all the Zoom setup, the publicity, and the relation to ICSE. Thanks everybody of these organizers that helped us in putting this together. It has been a really nice experience working with you. And of course, we also need, program first. We were able to put together a nice program. You see basically this is what is on the BotSE website, botse.org. We have the link later on in the slide set as well. If you want to look up what's coming up, all the times are in UTC, as you've probably are used to now at ICSE. And we have short videos of the papers, and we have time to discuss, and we have 2 great keynotes that you will hear about a little bit later on, and we have 2 short breaks, 10 minutes, just to stand up to do whatever you need to do during our sessions. We try to be very compact so that we don't have to stay like for hours and hours at a Zoom meeting, but have really quick talks and be able to discuss and then go through these various topics. And we have some open discussions at each of the sessions and at the end of the workshop, so to bring in ideas, issues that are open, and also talk about how BotSE might continue. Next. Yes, so we have 2 great keynotes. The first one will kick off the first session, Jordi Cabot, and then we have in the second session, Gregor Martinus. You will hear about those when we get to them, but we are really excited to have them here. Again, something maybe that's helpful that we're virtually now, because maybe not both of them would have been able to come to Seoul, but here in Zoom, we can bring in the best people to give you interesting insights on bots, and especially on the practical side also of bot development. So we're very excited and thankful to have them here. Some statistics, I guess for workshops, that's not the most important thing, but nevertheless, we had 8 submissions, a huge number, but we accepted 6 out of the 8. So we had really high quality submissions. We're really happy about that. We added 2 invited papers to round up the program. And this gives us our 8 paper presentations overall. We had 24 reviews and 28 comments in EasyChair discussing these submissions, which are 9,300 words in reviews and comments, which make up, as Emad said before, almost a TSE, or a bit more than a TSE paper. So quite a lot of discussions, and we're really happy that the community was so active here. And we are a truly international workshop. We also something we're really happy about, that we can integrate the big continents involved in software engineering. So from Europe, North, South America, and Asia, from submissions from 6 countries, and in the PC we have another 8 countries participating in this workshop. And with that, I give over to Emad.
Okay, so thank you, Stefan. So as Stefan mentioned, it is going to be virtual. If you didn't figure that out yet, we'll send you the room number later. But as for the program, that was a joke. As for the program, we will have 10-minute paper presentations. So we'll play the videos for these papers, and then The authors will be around to answer questions. So we'll have 5-minute Q&A sessions. Please ask your questions in the Zoom chat, and Glacia, our student volunteer, will be managing these, and we will be asking these later. As Stefan already mentioned, at the end of every session, we'll have 20-minute open discussion. So this will be managed by, typing in your need to participate through chat, and then we will prioritize and unmute you to speak, and we will discuss. And please don't hold your questions. So post them in chat as the presentations are going on, so that way we can move quickly through the questions. We don't have to wait until the end of the presentation to gather questions and then ask them, since we do have a short period of time. Workshop logistics. So usually we would have this slide to tell you where the bathrooms are and where the workshop dinner will be held. Unfortunately, we cooked dinner, but we can't deliver it. So this year we said, this is not our problem, not the organizer's problem. But Stefan has promised that we will have a really nice dinner in Madrid if everybody makes it there. So that's a reason to be there physically. Our website has all the information about the program, the preprints, the videos. It really has all the information that you need. Please pay attention that all the times in there are UTC. So, convert them to your local time zone. And we will be using the BotSE 20 hashtag to tweet about the workshop. And if you want to mention the BotSE workshop, please use our handle BotSE_WS. This would have not been possible without the really amazing PC members that we had for BotSE. We counted those words, and 9,300 words in discussions and reviews. So for a workshop, that is quite amazing. So thank you to all of the program committee who helped us contribute and have a really strong program. Okay, I think we're on time to start our first keynote. So it is my pleasure to welcome Jordi Cabot to give the first keynote about lessons that he learned from building a commercial bot platform. Jordi is a professor at the Open University of Catalonia. I have known, Jordi's expertise, I guess, are at the cross of software models and people. However, I got to know a lot about Jordi's work through his blog, actually. So he also writes a very mean blog, and he wrote one of the best blogs I've ever read about software bots. So I highly encourage you to read it if you haven't. Jordi kind of is a very unique person because he's a very successful academic, but at the same time, he seems to find the time to also develop commercial platforms, or commercial grade platforms, I should say, which is not an easy task. So I think he brings a very interesting insight to the community. And I'm super excited to hear what he has to say. Without further ado, I will pass it over to Jordi to share his screen and start his keynote talk.
Thanks for the introduction. I would like to say that I'm very successful with ChatKit on the commercial aspect of things. Unfortunately, that's not really true at the moment, or not yet. So we'll see. We'll take this opportunity to discuss some of the things we discovered when trying to be successful, commercially speaking, with ChatKit, and some of the things we have learned in the way, right? So let me just, okay. So ChatKit is a spin-off of my research team in Barcelona, the SOM team. And as you already said, I mentioned in the introduction, so our mission, the motto of the team is basically how we can use software engineering best practices to basically create better software faster, right? That's really the motto of the team. And to do that, we basically have 3 research lines in the team. One is about low-code development, so model-driven development, where basically we want to use modeling to semi-automate the generation of software. So from high design models to really the final software artifacts. Then you have a second line on artificial intelligence, especially applied to software engineering as well, how we can improve software development by using machine learning and other kind of AI techniques. And finally, we are also interested in open source and open data. So how we can reuse open source projects and open data sources to really improve software development. And this is interesting because in the end, ChatKit is really at the intersection of the three lines, right? So of course, as artificial intelligence, because in the end, the chat part is recognized with a neural network and so on. But as we will see, ChatKit tries to define bots at the high modeling, at the high abstraction level using modeling techniques. And it's an open source project where we have also tried to really attire some attention from the community and to get some contributors to help us in the development of ChatKit on the open source version of ChatKit. So let me just give you a very, very short introduction of these terms, bots, chatbots, and voice bots. So basically, a chatbot is a bot that has a chat interface. So basically, a chatbot can do anything that a bot can do, so automate processing, process event, and so on, but it's also able to talk and to chat with a potential user of the bot. And a voice bot is kind of the same. It's a bot, but now with a voice interface. This voice interface is typically implemented by going to a text description. So basically, all the voice bots, what they do internally is to take the audio that the user is speaking and apply to that audio speech to text component. And when you have the text, you process the text as if this was a chatbot. You do all the processing that is required. And in the end, you translate the response of the chatbot back to voice with the text to speech, right? So basically, if we look at the relationship between these concepts, you have a bot, a chatbot is a bot, superset of bots, and voice bot is just a chatbot with an additional layer for processing the voice part. So at the core of the chatbot, we do have, of course, an NLP engine, which is the key characteristic of chatbots. And this NLP engine has basically the key functionality of understanding what the user is saying to the bot, right? So the NLP engine has to classify the user utterance, which is the way we describe in the chatbot world, the input text of the user writing, in one of the intents that the bot accepts, right? The intents are the set of questions, or the set of requests that the bot is able to understand. So basically the goal here is, again, to take what the user is saying, try to understand this and classify it in one of the things that me as a bot, I should be able to respond. And then if I manage to do a match, so you manage to match the user text with one of my predefined functions, then I process that with parameters that I have collected from the user text, and then I process the text and respond to the user, right? So basically, we could say that the chatbots combine all the complexity of bots with the complexity of natural language processing. And this includes not only the classification, but also many other things that are maybe at the beginning are not so obvious, but that when you start trying to do a real or high quality bot, you face this issue, like typos, right? So for instance, in this bot example, I write a new letter and not newsletter. So the bot needs to be able to correct the typos of the user and still understand the question. You also have to deal with trolls, with sentiment analysis, and so on. So again, let's not be confused and assume that chatbots are easy, because in the end, when you really try to do a high quality chatbot, you understand that you are facing a lot of challenges. So I would say that you should think twice before building a chatbot. So let me explain how we end up building ChatKit. So once upon a time, so when we were young and naive, so we are still young, we're not that naive, there was a company that came to us and asked us to create a chatbot to help newcomers to the company products to write good bug reports on GitHub. So I say, okay, that seems kind of interesting to us because we love open source. We are interested in playing with GitHub. And this seems relatively easy because in the end, it's about creating a chatbot that will ask the user the questions that the user needs to reply in order to follow the bug report template that the company is internally using, right? So okay, let's go for it. Of course, things turn out to be much more complicated than what we thought, because if you look at what really implies this kind of this kind of chatbot to help users write good bug reports, you start to see that there are many components that maybe at the beginning you were not really aware of that. So you have the messaging channels, because they wanted people to be able to use Slack to write the bug report. There's the NLP or the NLU engine. In this case, for instance, Flow, could be IBM Watson, could be Amazon Lex, whatever. And then you also have the platform with whom you need to interact with, right? The GitHub or GitLab or whatever external platform. So as you say, it's not just about defining simple rules, it's about really creating a piece of software that needs to put together a lot of different pieces. So in the end, I think that we need to understand that chatbots are not just a toy, just a kind of, again, a simple set of textual questions and answers. It's really a complex software system that has text processing, that has conversational logic, that has messaging platform, that have external services, that have deployment problems as well, because again, it's not so easy to really connect all these pieces together. And as a piece of software, it has evolution, has maintenance, it's testing. So in the end, I really like this sentence from Tim Menzies that says that AI software mostly isn't about AI. And I think that's true also for chatbots and for bots in general, right? So maybe we tend to look at the AI, NLP part of the bot, but in the end, that's just one component of a chatbot, and most of their components are more kind of traditional software components. And in theory, we should and we could benefit from, say, good software engineering practices when building the bot. And I think it's very important to do that. So just to summarize this first introduction, at the beginning, we thought that building bots was basically writing this kind of rule. So if the user expresses the intention of opening an issue in a repository, the bot should reply in which repository, that would be the parameter, and then we just say in what platform this needs to be responded to. And that's basically how you build the bot. Okay, that's really the top of the iceberg. And really building a bot, as we say in the following, it's really much more complex task. And I think that, again, this is not something that you have in mind when you're starting playing with bots. So why ChatKit? So you see, the AI ecosystem is huge. I think that we are all know, we are all aware of that. There's really thousands of products. Same with bot platforms. So there's hundreds of chatbot platforms, both complete platforms, chatbot libraries, NLP engines, and so on. So why we wanted to really have another one? So when we started trying to build this bot that for the project about bug reports, we started by trying to choose the best chatbot platform for that topic. And we realized that, in fact, all the chatbot platforms that we were seeing had quite a few of issues that were not really reusable in this scenario. For instance, if you want to have an open source chatbot platform, then the first surprise is that most of the chatbot platforms out there are not open source. So our calculation around, we check around 50 different chatbot platforms, and only 15% of them were open source. So if you use any of the other ones, again, you enter already in the lock-in scenario and so on. So we didn't want to go that route. Then we also realized that they are not flexible. So if you want to create a bot for Messenger or a bot for WhatsApp, then maybe you're fine. You will find a good solution for you. If you want a platform that allows you to really connect with any external service that you need, then again, that's a much more difficult choice. Also, most of them only work with a single provider of natural language recognition. So some of them work with Dialogflow, some of them with Watson, some of them with Rasa, some of them with another one, but most of them only work with one. So if you need to provide bots that could be migrated from one to the other, again, that's not something that current alternative will provide for you. And the final and very important point for us is that most of the solutions that we found were very low level, meaning that if you just needed to write and stay within, let's say, the text-based part of the bot, so only text questions, textual answers, then you're fine. If your bot needed to do something more complicated than that, like again, accessing an external platform, many of these alternatives that you can find out there were basically forcing you to start programming in JavaScript. And we wanted to avoid that, right? So we wanted to really minimize the coding part of the bot, because again, as we saw at the beginning, we are more fans of trying to use a high-level descriptions of the systems, because this gives all the benefits and productivity and quality and so on. In fact, it's not just us that says that going up in the abstraction level is good. So Grady Butch has this famous sentence that the entire history of software engineering is that of the rising the levels of abstraction. And in fact, we believe that this is absolutely true also for AI in general and for chatbots in particular. So that's why we thought that in the end there was a gap in building a chatbot solution that was a model-based, that provides some languages for defining bot at the higher abstraction level, that was flexible and open source. So as typically in our field, we were asked to build a bot. We ended up building a bot platform. So even if I gave you some reasons why I think that was still the good option, it's true that in the end, probably there's also a part of this not invented here syndrome that affected us and motivated as well as to create a new platform. So let me just describe very briefly how ChatKit works so that you understand then some of the lessons learned. So as I said, ChatKit is a low-code solution. So basically, again, raising the levels of abstraction at what chatbots are defined. We created and we provide DSL, so domain-specific languages, that help you to write the bot behavior and the bot description at this high level, and that are independent of the implementation technology. So the point again is that you write the chatbot at this with these languages, and then you decide where to deploy the bot. And then our ChatKit engine is able to basically deploy the bot and run it over the platform that you have defined. So the concept of platform is another key concept in ChatKit. And again, platforms are defined with another DSL, so that this DSL allows you to describe what is the platform providing to the bot. And the platform provides two types of things. They provide actions that the bot can execute, and they provide events where the bot can subscribe to. So when you define the bot, you write the bot interacting with these platform definitions. So you are not really writing against the platform API. You are writing against the platform abstraction, which again is easier to do, is shorter, and so on and so on. And then when you are deploying the bot is when you actually, the engine translates this interaction at the language level into the final calls to the platform API. So this would be the architecture. Basically, I've already described the key parts. So the designer uses the intent language and the execution language to define what the bot needs to understand and what the bot needs to do for everything, for every match of the user input. And this execution package can use predefined platforms that are defined and provided with a ChatKit framework. This definition is then passed on to the runtime that is able to deploy the bot with the configuration and then connect the bot with all the either NAU providers, instant messaging platforms, external service, and so on, so that the final user can actually use the bot. Just two examples, so to give you a feeling. So these examples are going to use the chat platform. Note that the platforms can be organized in a taxonomy, so you can inherit a method from one to the other, and you can also refine and overload the methods. So if you just need a very basic chat behavior in your bot, you could define the bot using the chat abstract platform. This will allow you to redeploy this bot into any chat platform. So you define the bot once, and then you can deploy the bot in Slack or Messenger or whatever you need. Or if you need to have more specific methods of a specific platform, then you define the bot at the platform level. So here for the chat platform, basically we assume that there are only two messages, the post message and the reply. And then in this example, we are going to use the GitHub platform. So this is just a small subset of our GitHub platform. As you see, the GitHub platform offers a set of events that you can subscribe. So you can subscribe to new issue events, star events, and star events. So this means that every time that in the repository that you are monitoring, there's a new push or the new issue event, the bot will get the notification, then the bot can do something in reaction to that. So let's see with an example. So this is our Stargazer bot, very simple. The only thing that this bot does is to put a message, write a message on the Slack channel, celebrating that somebody has added a new star to your GitHub repository, right? So every time, if you then later on you go to our organization in GitHub and you star any of our repositories there, you will make me happy immediately, because I will see in my Slack channel that somebody from this wonderful community has decided to start our project, right? So how does this work? It's very, very simple, because in this case, there's no chat part. It's just kind of a pure bot. So there's an init state, so it's the initial state of the bot, and you can see that there's a transitions in this state, in this case, are triggered by events. So basically what we are saying here is that if there's a star created event, we go to the handle new star state, and if it's a star deleted event, we go to the handle star deleted event. So if you look at the first one, this handle new star event, the only thing we do is to post a message on the chat platform. Note that here, this chat is not really, it's at the abstract level. So which Slack installation, which channel, which token is needed to actually execute this is part of the deployment configuration, not part of the bot definition. So the message just says that you now have a new star on the repository and gives some information about the repository that has been started. And then you go back to the initial state, very simple. If you need to chat, things, of course, are a little bit more complex. So in this case, we assume that we are using, again, the Slack to report back a problem with, in this case, a plugin. So then the bot asks some questions about the operation system and so on, so that you can create the bug report. So in this case, we have this additional language, not only the execution part, but the intent definition part, where I say, okay, simplifying again, the user can say two things to the bot: that the software is not working, so that he wants to express the intention to open a bug, or he can also, as part of the conversation, tell me which OS version is using, so that I can then replicate the error. So in the input side, you see the training sentences that basically helps the NAU provider to classify the user text in one of these two intents. And same as before, now the triggers of the execution language of the state machine are not events, but user inputs. So here again, if we detect that the text that the user has written in Slack classifies as the text of type open bug based on these training sentences, then we go to the handle new bug state, where we will post a reply to the user, ask for additional information, in this case, the version of the OS system. And then again, at this point, we expect that the user will tell us what OS version is using, again, based on this training sentence, and then we move on to the next state, right? If it's trying to say another thing, we can print an error or go back to the same state and so on, okay? But that's how it works. Again, everything is defined with these DSLs, and then at runtime, we can decide where to deploy the bot. So the tool, as I said, is available on GitHub, plenty of repositories with different connectors. And now let's move to the lesson run. So again, that's the main topic of the talk, but I think it was needed to really do this kind of a motivation and introduction to ChatKit, so that you understand where we are coming from and what are the issues we are facing right now. So we started in May 2018. The first commit was on that date. So it's been 2 years already. And just to give us some more background, so in the team, we actually create plenty of tools. So we have, these are all the tools of the team. But as any other research team, most of these tools end up abandoned very quickly. I mean, once the paper is published, most of the tools get abandoned, right? Because most of the time, the tool was really a proof of concept for the paper. So we have created many tools, but we realized that contrary to many of these other tools, there was some interest in ChatKit. We believe that there was kind of a gap again in the market for that kind of solution. And that's what motivated us to not abandon ChatKit, but instead starting to really put more hours on ChatKit and start this industrialization and commercialization process. Of course, again, we were very naive and we were not aware of all the things that this implies. So let's see some of the things that we have learned and had to decide in the process. So if we start at the organizational level, you really need to be a polymath to create a bot platform. So there's plenty of technology around bot creation that you need to learn. Again, natural language processing, sentiment analysis, domain and specific language definitions, working with messaging platforms, dealing with APIs. all this kind of was more or less expected, so we already were prepared for that. But then you realize that again, when you want to transform this proof of concept into real tool, there's a lot of additional technology that you need to learn. InfluxDB to store the session data so that you can monitor the bot behavior, reverse proxies, visualization library for the bot dashboard, WebSockets for communication, Docker for images. Again, many of these were not really aware from the beginning, and it was really a kind of a tough learning experience to really try to cover all these technologies. So really, as I said before, right, building a bot is really involves a lot of components, and you need to be ready for that. And of course, creating a commercial tool is boring in the sense that when you are doing a research prototype, you can focus on the cool things. All the rest, kind of documentation, quality, nice interface, all this can be ignored. It's a proof of concept. Once you start trying to sell something, people will ask for all the kind of high quality and commercial type of stuff that as is expected of a real tool. So basically, when you are doing prototypes, you are just kind of solving research challenges that are provided by typically big companies, maybe. So you create a proof of concept, and then if anything, there will be a technology provider that if that provider thinks that your proof of concept is interesting, then maybe we take it and transform it into a real tool. Once you are the one that playing both roles, then you need to take care of all the industrialization part of the process. More challenges at the organizational level. Well, some of them are just common to any open source project. So we have here in this workshop, there's people that are expert on that as well, right? How do you onboard contributors to the tool? How do you try to track contributors to ChatKit so that they can help you by creating new platforms so that you have more connectors available for ChatKit? Giving support to users. Many times users that they don't even say thank you. So again, it's not always nice. And then the cost of maintaining external contributors, right? So there's people that contribute some code. For instance, there's a Twitter connector for ChatKit, but this Twitter connector was created for the previous version of ChatKit. Now it's not working with the current version of ChatKit, and that person is not contributing anymore. So it's nice to have people contributing, but then there's a lot of cost on that. And we had to be very pragmatic. We are just 2 core contributors to ChatKit plus 2 other people working part-time on it. So that makes 3 full-time people. Not even that. So at the beginning, we wanted to do things right. So we had official releases. Then we realized that was too much work. So we moved to core releases. So the platform was not included in the release, just the core engine. And now we don't have releases at all. Again, because that's a lot of work. And at the moment, that doesn't seem to have a good return on investment. So we're now trying to use Docker images as a kind of intermediate solution. We don't support other versions. And there's no backward compatibility. So again, these are some drastic decisions, but they were needed to really have enough manpower to do the things we wanted to do. Let's move to some technical lesson learned. The language has evolved a lot. And part of that is because we didn't create enough bots at the beginning. So we created a language that was useful for the bots that we created as for the first contract and then for some experiments. But then we realized when there was another guy that wanted a different bot, we realized that the language that we had developed for the first version of ChatKit was not enough, was not expressive enough. And we had to basically create a second version of the language, which is the one that you saw based on state machines and semantics. Of course, changing the language changes everything. And it was really a painful process to move from one language to the other because we had to change the editor, we had to change the examples, we had to change the documentation and so on. So again, I think it's really important that if you are creating a chatbot platform, you make sure really you define well what are the kind of bots that you want to define and make sure that the language is really targeting those type of bots. You also need to decide on language granularity. So it's always difficult to know, for instance, in our case, if live chat, which is something that we can do with ChatKit, should be a primitive in the language so that it's easier to define, but then it's more complex to implement on our side as part of the core engine, or it's something that basically you can do by connecting to live chat platforms. Then I think it's also important to choose a combination of textual and graphical notation. So right now we have a textual language for writing ChatKit, and then we have a graphical language for displaying and reading the bot definition, which is more easy. It's easier to understand. But again, that was part of the process, so we didn't know at the beginning whether to go for one or the other, or combine them and so on. And then you also need to be careful not to reinvent the wheel. So we realized that when creating the the execution language, we were adding more and more primitive because we wanted to define more and more powerful bots. And at some point, we realized that we're kind of just reinventing Java or a Java-like language. So at that point, we stopped complicating our own language and moved to, in this case, X-Based, which is a part of the Java-like language of the Xtext family, which integrates well with the editor. So again, be careful to really be creative with the language when needed, but not when it's not needed. Choose your stack. So in my team, we are, since we work a lot with modeling tools, we are basically very familiar with Java, Eclipse YMF, which is a modeling framework of Eclipse, Xtech, which is a framework for creating new languages, new textual languages, but from a modeling perspective. So this was our natural option. We didn't really think through whether that was the best option long term. Again, that was the faster option for us to start. And again, this has a trade-off. So we are good, we're fast at the beginning, but now if you realize many of the AI libraries and components are not really based on Java, are based on Python, or some of them also available in JavaScript. So this means that connecting with them is not always as trivial as we would like. So I think that's really important. I think it's also important to think long term, and research prototypes are basically pure technical debt, because again, all the decisions that you may make during the prototype is just to get the paper out as soon as possible. So don't really care about any of the quality aspects, and we are paying that. So they're still part of the engine that were developed for the first paper on ChatKit, and we still didn't have the time to really improve that. We had MapDB at the beginning because it's an in-memory database. It was easier to use, didn't require any infrastructure. When you need to really go to a multi-user, multi-session bot, MapDB is not working. It's not working well enough. It doesn't scale, so you need to move to InfluxDB. And again, this implies re-implementing part of the engine, re-implementing part of the monitoring API. So I think that, as usual, some of the decisions on the short term are good, but then you pay the price later on. Security is something that we had never thought about it before, but of course, once you have a bot in your website, it's subjected to attacks. Distributed denial of service attacks could be done via a bot, right? So by just other bots simulating that are talking with your bot, and this is important not only because they can collapse your server, but they could be very expensive. So if you're not controlling the quota of the, for instance, if you're using Directflow, there's the free tier, but then you have to start paying. So if you don't really control who is using the bot and put some limits on that, you could end up paying a lot of money via one of these attacks. Other security concerns. Some companies don't want to use Directflow or even Watson or any of these alternatives because they don't want the data to go to the cloud. So this means that if you have a chatbot platform that only works with Directflow, you will lose this client because they will want to use a local solution, local offline solution for the chatbot. So you need to be ready to provide both types of infrastructure. There's also privacy concerns, because for the bot to be of good quality, you need to basically monitor the bot behavior to identify which are the questions that the bot is not able to answer, at what point of the conversation the users leave, so that you realize that there must be some problem at that point and you need to fix that. So this monitoring data can generate some privacy concerns, especially if you are linking the data to some user data, maybe not the username, but some IP, some other information. Again, all these things, you never think about this when you are developing the research prototype, but as soon as you want to start getting paid for the bots, they all become concerns. On the NLP side, plenty of things also to discuss, right? NLP engines, they don't speak Catalan. You may think that's maybe not that important, but it is, because, for instance, if you want to sell a bot to the public Catalan administration or to the Barcelona city, right, they will force you to support Catalan as a language, right, because that's an official language for us. So what do you do here? Okay, so again, you may need to combine more than one NLP engine to be able to support non-mainstream language, mainstream language. So again, if you are English or you're French or even probably German, you are fine. Once you start with even Brazilian, probably is more than fine. But when you start to other languages, it's complicated. And it's not only that they don't speak Catalan, it's that if you have to develop a bot for the Catalan region, you need to support both Catalan and Spanish. But you may want to be able to support them at the same time. So not that you let the user choose whether they want to talk with the bot in Catalan or in Spanish, but we meaning the Catalan people, we typically mix both languages in the same conversation. So probably the bot should be able to understand both languages at the same time. And again, that's something that if you try to do that with Dialogflow, good luck with that. So that's kind of a complications as soon as you get out of the mainstream English-only chatbot domain. Another curious question is that everybody wants to have sex with your bot. So trolls are also a problem with bots, right? They're a problem with in any kind of internet discussion forum, so bots as well. So why is that a problem? Because as a brand, you don't want to risk going viral because your bot gave a wrong response to a troll question. So imagine that you are any kind of public company and have a bot, and somebody says, I want to have sex with you. And the bot says, sure, whenever you want. Okay, they will take a screenshot of that, put it on Twitter, go viral, and that's something you really don't want. So it's very important you have predefined intent libraries, not only to recognize typical intent like hello, goodbye, thank you, that you don't want to repeat in every bot because every bot will have the same intents to recognize. I mean, everybody is to be able to recognize hello intents or greeting intent in general. You also want to have a library that recognizes all these kind of troll messages and just provide a very neutral question, very neutral answer to all of them to avoid these kind of issues. Just as a curiosity, in one of the bots we were building for a company, they gave us the list of questions that they wanted the bot to be able to deal with. There were 3 examples, and out of these 1,500 were about these troll questions, so that the company had already listed because they wanted to be sure they were protected against that. So they spent half of their time defining all the potential stupid questions that people could ask the bot to make sure that the bot would be able to cover that. Testing of chatbots is as well largely an explored area. So in ChatKit, we use Botium, which is kind of a Selenium for chatbots. And you can use the Botium to record conversations and then store these as use cases, as test cases. But we need much more than that, right? So for instance, we need to have some automatic generation of test cases from the bot definition, like we do for other kinds of software. And we don't have that yet, but that's something that it's worth exploring. And this is especially worth exploring because it's curious to realize that the quality of your bot may decrease, not because of you, but because of your NLP provider. So again, imagine that you're using Dialogflow, the bot is working perfectly fine, and then Google decides to release a new version of Dialogflow with a new version of whatever internal library that is supposed to work better, but for your bot, in fact, it works much worse than before. And that's not something that you control, maybe not something that you are aware of, because you may not even know that Dialogflow created or released a new version. So suddenly the quality of your bot is starting to decrease. So I think it's very important that in this case, there's a lot of continuous test cases that make sure that the bot is still performing well. And more is not always the better. So we have seen before that you need to define training sentences to recognize what the user is trying to tell you. But adding more training sentences is not always a good idea because at some point they will start overlapping with the training sentences of different intents, and this will get the bot confused. So it's really an art somehow to really find the best combination of training sentence for each intent. And you cannot assume that, again, the more is the better. And in our experience, this last point is also very important, enumerations. So instead of trying to match, so you imagine that you are creating a bot that gives you the weather of a city, right? So the user would ask, okay, what's the weather like in Barcelona? So if you predefine the list of cities that the bot needs to understand, Barcelona, Madrid, Paris, and so on, the quality of the matching will be much better because Dialogflow will not try to match any string, but will just try to match a mapping and enumeration. So this really improves a lot the recognition. On the business side, some surprises. So we put a lot of time and effort in creating a nice language for the end users, a nice editor. They couldn't care less about that. Most of the users, again, that depends on who is your target profile, right? So if you're targeting independent consultant, then maybe yes. But if you're really targeting the end users, they couldn't care less about your interface. They don't want that. They don't want to write bots. They want to give you the data they have, and they want you to create the bot for them, right? So in several meetings, we presented ChatKit, and they said, no, I have an Excel file. I give you the Excel file, you create the bot, you show me the bot. So I think this was also kind of an evolution that we did internally. So more than selling a tool, we are moving to selling a service, right? Then we have seen that there's plenty of chatbot solutions. So it's very important that you really try to find your niche, your way into the market. In our case, as I said, we didn't believe that there was a market for just selling a premium version of ChatKit. And based on that was the original idea, kind of having this traditional open core model. So ChatKit was open source, and we would be selling just some add-ons premium version. Then when after time to show the ChatKit to the user, we understand that, as we saw before, that they want more of a service, that they want just to give you what they have and you create the full chatbot and host the chatbot even yourself and monitor the chatbot yourself, improve the chatbot yourself. They just want to the chatbot working. So that's why we are moving to this more of a tailor-made bot for some clients, plus some predefined bots for specific domains, like the plugin that we have for WordPress. But again, disclaimer, I mean, we're just starting the company side of things, so it's not like we have the recipe for success here. More things that we learn, just a couple more minutes. So it's also surprising when you start showing or creating bots for people, because you think that they will care a lot about the quality of the bot or some aspects that core features, and then they care about the color of the widget, right? So if you are releasing a bot for the website of a client, probably the first thing the client will complain about is that the color of the widget of the bot doesn't match the color of the website, or the logo of the bot or the logo of the widget is not the logo of the website. So I think that, again, you need to understand the priority of the clients and sometimes just forget about your own internal roadmap of very cool features using BERT to analyze text, sentiment, blah, 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 and realize that in the end, it may be more important to tune the CSS of your widget than really provide the latest advanced feature. And for the bot owners, they all want a dashboard. Again, we didn't have a dashboard in the first version, but it's clear that as soon as you start talking with clients, they all want a very nice dashboard that shows them what the users are asking to the bot, how the bot is responding, again, what the bot is not understanding, and so on. So a chatbot platform needs to have a dashboard. And they also want all of them, the bot learn by itself, which I think is kind of risky, because you don't want the bot to learn the wrong things. But again, I don't know if it's because they see this in the news, but they all ask you whether your bot will be able to improve itself. Okay, it's more of an iterative process. The final reflection is, okay, maybe you should think twice about creating a spin-off if you are in the university. It's been more than 1 year of paperwork because the IP, so the intellectual property of what you do, is shared between you and the university. So if you want to create a company out of the work that you did as a researcher, then the university has to transfer the IP to the company, even if you are also on both sides, right? Of course, the university will take a cut of the company, may put some limits on how much you can dedicate to ChatKit, to the spin-off. So sometimes it's kind of confusing as a researcher, because on the one hand, they tell you that researchers should create companies because that's very important for the university. And then once you try to create a company, they say, yeah, it's great, but then you will not be able to run the company because you cannot put more than 20% of your time in the company. So, what the fuck, right? So, sorry. And it also affects your publication strategy. We have not done that with ChatKit. We try to publish as much as possible. But it's true that depending on what you publish, then they tell you that affects the patenting possibilities or the IP and so on, right? So again, I think it's really a complex process. And if you want to create a spin-off, then really look for win-win situations. So to make sure, I think it's very important that you make sure that even if the spin-off fails completely, all the people involved in the spin-off get something useful out of it, right? So for instance, I have one of my postdocs, Wendell, which is a co-founder of ChatKit, move completely his time from research postdoc to ChatKit co-founder. So I think it's very important that even if the spin-off at some point fails, he gets something important out of it, in this case, of the experience and the kind of improvement the CV, right? So I think it's important to always keep in mind this win-win. So what I would like to do next, I mean, if you teach any course involving bots, chatbots, NLP, DSS, I think that I would like you to consider using ChatKit as part of your use case or practical exercise. I think that ChatKit can bring some benefits as a kind of a packaged platform, open source, and this DSS. So that could facilitate your students to build some interesting chatbots without putting too much effort. So I think it could be interesting for you. And also for the research platform, one of the goals we have with ChatKit is that ChatKit could, say, speed up the research on the bot domain, both on the bot for software engineering and software engineering for bots directions, by giving you, I mean, you, a research community, a kind of a base platform with a lot of already predefined components that could help you to speed up the process of creating bots for different experiments. And that would basically, thanks to ChatKit, would help you to really focus on the research challenges instead of having to create for each experiment all the connectors, all the features, just to get the first bot started, right? So I think we all agree, as I said, that there's plenty of research to be done on this goal, the testing, automatization of bots to promote diversity and inclusion, or to take online harassment. So that, and all these topics, I think that either you start creating your bot from scratch, or alternative we'd love for you to use ChatKit and develop your bots on top of ChatKit. So if that's something that you're interested in, I mean, we'd really love to work together. Thank you for your time and your attention.
All right, thank you very much, Jordi, for a very nice and colorful keynote. I could feel the pain through the Zoom channel. So yeah, so right now we'll open it up for questions. There were a number of questions that came through as we were as you were speaking. So I'm going to, so I have the names of the participants who asked. I'm going to open it up, and you can unmute yourself and ask the questions directly, just so we can have a little bit more of a live discussion. So Elahi asked the question about what a good report, bug report is. So Elahi, do you want to unmute and ask your question directly?
Hi, thank you for your presentation. Yeah, my question was about the bug report. I guess I read your article before. I think you had an article about the bug reports. You mentioned good bug report, and I guess because I'm working on a chatbot for good and bad bug report, my question is, what did you mean by good in a good bug report, and how your chatbot could measure and help developers to write a good bug report? I guess based on the article that I saw, you only tell them what field is missing. Is that all, or what else did you cover?
Yeah, so that's basically the point. So we don't define what's a good bug report. It's just that, as you know, every company may have a different template for writing bug reports. What we want is to make sure, via the chat, that the user that wanted to open the bug report was providing all the information in the template. So ideally, the bot would make sure, by asking questions, which is a better way to do this interaction, that you are providing the information that then you will need to replicate the bug report. So it was more about using a chat interface instead of just writing the bug report and checking it afterwards, so that there's a kind of a faster turnaround in the creation process of the report.
Okay. So I'm going to open up the next question. It was originally posed by Oscar. And it was, so I'll get Oscar to ask the question, but I also want maybe Neil and Nicole to unmute because it seems like they had follow-up questions on that question. Maybe we can ask the question and the follow-ups at once so that Jordi can answer them all together. So Oscar, do you want to unmute and ask your question?
Sure. Can you hear me well?
Yep.
Yeah.
Great. Jordi, thank you very much for the great talk. It was very interesting, and I'm looking forward to using ChatKit in my class and in my research. Yeah, so my question was about the variability of natural language, right? So how can a chatbot understand the so many ways of expressing a question, a bug, and so on?
Okay, and I know Neil, you had a little bit of more of a refinement to that question. So, do you want to follow up on that, or was it?
Yeah, so I think it's the same question, but from a technology point of view, using the low-code framework, which I think is more sort of symbolic and rule-based, and how well does that play with these unstructured queries? And can you just treat that as there's some black box component that will process the input, and then you can make it work within the low-code approach?
Yeah, so we are not NLP.
Just before you answer the question, I think Nicole had a follow-up as well. So I just want you to catch it all so then you can answer all at once. Yes, Nicole, did you have something to add here as well? You can, yeah, you're unmuted.
No, it was just another possibility to deal with variability of natural language could be also to leverage some automatic approach. I don't know, we can try to identify automatically the intent of the user based on the analysis of his utterances. So I was wondering whether you have any possibility to integrate the results of such an automatic approach, which could be machine learning, could be unsupervised, clustering of similar question, I don't know, whatever you think is useful. So whether it is possible to integrate the results of an automatic analysis of the user utterances and the current framework.
Okay, thank you.
Yeah.
Jordi, now it's all yours.
Yeah. So we are not NLP experts, and we don't pretend to be. So we don't actually do the processing ourselves. We rely on external tools. So again, if we go to the Dialogflow example, we do have an interface in ChatKit that helps us to move from Dialogflow to another system. But if we stick to the Dialogflow example, what Dialogflow does is they provide a multi-classifier, right? So basically, what you do is you define training sentences for each intent. So these training sentences are examples of how the user could express a given intention. You give these training sentences to Dialogflow, and based on that, Dialogflow will train a neural network using your training sentences and some synonyms to enrich the set. And with that, every time that you give a specific user input to Dialogflow will try to match this input with one of the intent that has defined, and will give you the intents that are a better match for that text. So basically from Dialogflow, you get the list of intents that are a match for a specific input with some confidence level. And from that, you can define a minimal threshold. Say, okay, if there's no more than 50% confident, then I assume that I didn't get what the user was saying. Otherwise, you just take the one that has a better confidence and you go from there. So basically, again, the key aspect to deal with variability, just use training sentences. The more you put, if they do not overlap with other intents in the same bot, the better, because therefore we have more examples to work with, right? Then we use a state machine. So it's not really rule-based, it's more than that. We started with a partial ordering language. So basically you could define some intent and then some ordering between them, but now it's a state machine. And you basically the transitions between the states are triggered by the intent. So we kind of really decouple the recognition part from the behavioral part. And we just get the information from Dialogflow of what's the intent that they use, what's the intention of the user, and then based on the state where we are in the state machine, we move and we react to that. Hope this answers the questions.
Okay, thank you, Jordi. So there's another question from Philip Philip, do you want to unmute and ask your question? Or I see Philip is not there. Okay, so maybe we'll pass that, and Diego Costa had a question. Diego, do you want to ask a question? You can just unmute. There you go. You're unmuted now.
Yes. Yeah. Thanks for the talk. I think it's actually super interesting. I'm also looking forward to try the tool. My question is still on the NLP side of the thing. So it's about data set generation in a sense. So I guess when companies come to you for provide a chatbot, they already have some sort of data set in which you could train the NLU, right? And my question goes more into situations in which these interactions between like humans and the service was not available before. So if you want to create a bot, let's say to apply for software engineering purposes, so we are like without any data set to even start training this NLU into recognizing user inputs. So the question is, do you know of any tool how would go about how to better define a good data set for this training, or if there's any tool that, let's say, amplifies data set so we don't have to like specify all the ways the user could interact manually. So it's more about NLP still. Thank you.
Yeah, so you are completely right. Some companies, so for instance, our own university, the student support, and they get around 20,000 questions per month on a student support about, you know, payment dates, exams, exam reviews, assignments, so on. Okay. And they do have a very complete Excels because they outsource this to external companies that are the ones in charge of responding to the student, because again, that 20,000 is just too much for doing internally. And they have some really Excels with examples of what a student can ask and then how you should reply. So if you have that, then it's straightforward. What if you don't have that? So two answers on that. First, there are some data augmentation techniques, which basically would help you to give just one example per intent to try to generate automatically additional examples. You could use synonyms, paraphrasing, and things like that. But then the other one is really the monitoring part. So even if you believe that you know your users, and then you create that bot that should be perfectly working because you think you know your users, as soon as you put the bot live, you start to discover that in fact the users may have in mind different questions. So again, you predefine, say, okay, my bot will answer these 5 questions because that's what the user wants. And then you realize that in fact, no, the user is asking a different question or is using a different wording for the same question that you had already in mind. But here the only option is to really have this monitoring dashboard where you have all the user input that were not recognized, and then you keep iterating. So we explain to the clients that just releasing the bot is just the first step, because really it's impossible to really predict how the people will use the bot. And the only way is to have a weekly or at least monthly meeting with them where you go through the session data with the monitoring, and then you start asking the client, okay, the user wanted to know about the billing process. Is this something the bot should know or not? If yes, then you add this to the bot definition. Or they use, again, a different wording. Instead of billing, they say, I need to pay, or instead of need to pay, how much does it cost? And then you start refining, but there's not really more magic than that.
So maybe I have just a quick follow-up on that, Jordi. So right now what you're saying is that this is somehow of a manually intensive training process that maybe you can ease by having some sort of dashboard. There's really no automated approach to do this, right, as of today?
So as I said, the clients always want that. They want the bot to magically learn by itself and kind of improve based on the past interactions. Yeah. And I understand where they are coming from. But the problem is, what if the user, again, let's go back to the troll example, right? So what if the user asks stupid questions of sex-related questions? Do you really want the bot to learn from those interactions? Yeah. So I think at the very least, the dashboard needs to present the interactions in a way that they are easy to review. And then once you click, okay, this one is good, then of course, we should somehow be able to add this to the bot and to redeploy the bot automatically. But I still think that there's a supervised step there just to prevent the bot learning the wrong things.
Okay. Okay, thank you. So then I think the questions, and I'll open it up to two. I think there's some commercialization related questions from both Philip Leitner and from Walid. And Neil asks about your exit, but we'll save that for the exit and the ending of the keynote. So Philippe and Walid, do you want to ask your questions? Maybe we'll start with Philippe and then Walid.
Yeah, sorry. So one question that I had, and you kind of, after I asked the question, you kind of touched upon it in your talk anyway, but maybe you want to explain a little bit how you actually got started with, running an open source project as part of your research, because we tried doing similar things in the past, and normally it becomes a bit of a kind of a hack very quickly. So very quickly, somebody in your team probably needs to do some stuff that's not actually their job, right? Or did you have funding to actually
No.
right from the start to have people work on this project, or did you kind of misuse some taxpayer money for that in a creative way?
So I think this is really...
So just before you answer it, Jordi, Walid, do you want to chime in as well? Because I know you had a related comment, and then Jordi can take it from there.
Yeah, thanks. So I didn't really have a question, it was a comment, but since you're giving me the chance, I can follow up on a question. I mean, maybe you could, the related question could be, if you think back now, based on your experience, would you do something differently based on, for instance, the timing of the spin-off? I mean, would you, for instance, say that at one point of time you started experimenting and you started coding, and then on what point of time maybe you should have switched earlier or so? So I don't know.
Yeah, so unfortunately it's true that creating tools doesn't really count towards your research promotion and your research career, right? But I think that's really a problem. So every time that my university tells me that there's this San Francisco manifesto that you should not really count only publications, but impact and blah, blah, I always ask them how many journal publications are equivalent to a good open source tool, right? And they never reply to that. So if you look at this, I think that you are seeing this slide with all the tools of the team. Many of them, we use these codes to basically identify that many of these tools are archived or are not under active development. So we really like to develop tools, our team, and we believe that this is good, but then we end up basically abandoning most of them just because we don't have the manpower. I think that the only reason we kept going with ChatKit is because from the very beginning, there was a feeling that there could be something there. And there was a combination of the feeling and the person, in this case, Wendell, that was brave or naive or stupid enough. I know he's listening, so that to really say, okay, let's take the risk of pushing forward ChatKit, even if I know that if I do that, I may be killing my research career. So that's really a tough situation, right? In terms of what we have done differently, I think that the main issue is that when we started ChatKit, we didn't know that we wanted to transform ChatKit into a company. So many of the decisions we made were more around building quickly a research prototype to show some ideas that we had, and not really in having a robust foundation for what is now ChatKit. So we end up having to re-implement many of the components 2 or 3 times, and this has really, it was very good to have a quick start at the beginning, but has to slow down the process later on. So if you really know that you want to create a commercial tool, you should really start thinking about that from the very beginning.
Okay, I think I'm going to ask Philip's question again. So the way that you got started, and initially, I assume you have to fund these things, and you have to. Did you just manage that through the university, or was that something that you kind of initially bootstrapped?
No. So in the slide when we started presenting the naive version of ChatKit, so that company that wanted to have this bot for bug report, they offered us a contract. So the first year of ChatKit was paid with that contract. And they were happy that in the end we didn't recreate the bot that they wanted, but we ended up having ChatKit, and well, they were very open to that because I guess they learn also from the process. They of course they were friends, and they wanted to also compare the matching quality of different providers with English and French. So we did some experimentation with them, and they were happy. But basically, we used that money to fund the initial version of ChatKit, so for the first full year, and then we used other projects of the team that were not about ChatKit, but basically we took some of the money to keep paying for the development. And also ChatKit, again, in this win-win situation, has been used in other projects of the team. So we had the national project on open data, which was about helping citizens exploit open data sources. That was a national project that started even before ChatKit existed. But what we did, again, in this win-win situation was to say, why cannot we use ChatKit or chatbots as a front end for citizens to exploit and to ask questions on the open data sources published by the city of Barcelona, right? So if Barcelona publishes the schedule of the buses and hospitals, addresses, or whatever, why not using a chatbot to help people ask questions about when the bus is arriving or what's the best way to go to whatever, right? So we somehow try to embed ChatKit in the projects of the team that were already running and where it made sense. And that helped us also to then redirect some of the resources of the team to ChatKit, again, in this win-win vision.
Okay, I see. So it was basically bootstrapped initially kind of thing.
Yeah.
Cool. I guess, Wally, did you have a follow-up or was it a separate question? You're muted. Sorry, I'm going to unmute you. Go ahead, sorry.
Yeah, thanks. So no, just a very quick follow-up. I mean, wouldn't you consider it actually as a good thing that you did in the research stage a quick and dirty solution, because for the IP issues and IP right, you could say later, yeah, everything that is clean and scalable and reliable is actually at the company, and the other things are actually they are done at the university. Is it not easier actually to, I mean, just
I'm not sure. In the end, ChatKit is open source, so you could think that being open source, the IP issues would not be important, right? Because in the end, so as I jokingly tell my university, it's easier for somebody external to the team to fork ChatKit and to basically make money with ChatKit than for us ourselves to do that, because we are in the university and then there's the IP protection. So I think it's also always difficult because lawyers at the university don't understand the concept of open source. So I think that it's not that obvious what would be the best solution here.
Okay, thank you. So I'm gonna ask maybe the last few questions just to save a bit of time. So Neil asks about the translation. So with a commercial, are there any commercial tools that can help with the translation? I know probably this is, yeah, anyway, go ahead.
Yeah, so if we go back to the Catalan example, right? So as I said, there's not really any major provider that supports Catalan. So what do they do? The Catalan bots right now, there are very few, but some of them exist. They do Google Translate. So basically they take the user input, they use the Google Translate as a service, they take the Spanish version, which is the closest one. Then all the bot is defined in Spanish. They process the Spanish translated text, and once they have the response from the bot, they go back to Google Translate and translate this to Catalan. Yes, that works. That works up to a certain point, but that's a solution, right? I don't think it's a perfect solution, but that could be an option if that's the only option you have. I think that we want a different option. There's at least one good library, good bot framework that supports Catalan, which is called NLP.js. So for us, here the point would be to make use of the flexibility of ChatKit, which is not really linked to any specific provider, and have a connector with NLP.js, same that we have one with Directflow, and basically be able to offer one or the other depending on what the user wants, either Catalan or online, offline, because NLP.js is local, so it's a library that you can embed with ChatKit, so you don't need to really go to the cloud. And so I think that's more the way we want to go instead of just doing the translation part.
Okay, thank you. So another question was from Oscar. So Is the chatbot for bug reports, is that available? Is that something that people can use?
No, but it's something that can build very easily, right? Now we have done it with experiments. It's not really I don't know if it's one of the examples that is published. The Stargazer one is published in the repository, but it was the goal was not really make a perfect bot template. But I think that could be an example of one of these collaborations that I was mentioning, right? So if any of you wants to experiment with using chatbots for bug reports, instead of, again, creating your own Slack connector, your own GitHub connector, your own connector with Dialogflow, let's use ChatKit, let's talk and make it happen.
Okay, so Oscar, I guess you have your course project set up for your class. Okay, and the last question, I think, which is a good question to end the session, comes from Neil, and it says, most important question, when is Jordi's $1 billion exit?
I'll let you know. I mean, of course, I think that ChatKit has to really, honestly speaking, has to go. One is learning. I think we have been learning a lot, myself especially. I'm not really a core programmer, and as part of the process, I think I've been learning a lot of things. But of course, we also hope that there's money at some point. We have funding for next year. We got some funding from the Catalan government, which is devoted to startups. So we have funding for all 2021. But at some point we need to make money, because otherwise ChatKit will die in a few months, right? So if Neil has any contact that can pay this $1 billion exit, please put me in touch.
All right, sounds good. When you do, though, don't forget BotSE, huh?
I will sponsor BotSE.
Anyway, Jordi, thank you very much. This was very insightful and very interesting. So I'll thank you one more time with a virtual clap, I guess.
Thank you.
We will be moving on to our first, I would say, talk. So this is, the next talk is actually an invited paper, and we are very happy to have that paper at BotSE. It is basically a paper about an answer bot for Gitter. I believe that Esteban is here. So at the end, after the presentation, after the short presentation, we will open it up for questions with Esteban. So feel free to chat your questions in the chat window, in the Zoom chat, as the talk is going on. So without further ado, Khaled, please play the presentation for the answer bot for Gitter.
I am Esteban.
Yes, sir.
Hi, I am Esteban Parra. I am presenting our experiences building an answer bot for Gitter. This work was done in collaboration with Ricardo Romero and Dr. Sonia Haydock at Florida State University. Nowadays, developers have started using instant messaging platforms to communicate with each other, especially when you're dealing with distributed development teams. They will use these platforms to communicate with each other and coordinate their efforts during the development of the project. A recent study by Kaffer et al. Found that Gitter is actually the most popular instant messaging platform in open source development. Developers can ask questions in these channels. They are usually chats, so they can ask questions to other developers to get responses in real time. However, we find that some of these questions may not require a specific knowledge from the developers on the project to be answered, and they might have been already answered somewhere else. To address these questions and help developers to focus on the questions that do require project-specific knowledge, we devised the Gitter ANS framework. In our framework, we have that whenever a developer posts a new message to the channel, we analyze the message, and then it will move on to our three components. The first component is the question detection component. This component will analyze the message and determine if it is a technical question or not. If the message is not found to be a technical question, it will stop processing the message at this point. If, however, the message is found to be a technical question, the message will be moved on to the second component of our framework, which is the search for answers component. In our search for answers component, we take the original message posted by the developer, send it to a query, send it as a query to a custom Google search that will search on Stack Overflow and return a JSON result with the top post from Stack Overflow that are found to be related to the original message. Once we have this JSON with the results of the answers to this question, we move this to our third component, which is the answer processing component. This component is mostly in charge of parsing the JSON result and posting that result as a new message to the Gitter channel where the original question was posted. Here we see an example of how the framework works. On the left side, we have our framework. On the right side, we have a set of messages that have been posted to a Gitter channel. So first, we have one message that was posted by the developer. So for the question, it was sent to our Gitter ANS framework. Then it was deemed to be a question. It was posted here as the question, and then the result that the search for answers component found using the Google custom search is posted as an answer, as a new message into the channel itself. So in here we can see the top 3 posts that were found to be relevant in Stack Overflow. Afterwards, we see 2 messages that are deemed not to be technical questions, so they are left as they are. Then when the user posts this next message, that one is also found to be a technical question. So I'll go back to our Gitter ANS framework, found to be a question, and the answers that, or the potential answers found by the framework, and then posted as an answer to the channel. For evaluating our framework, we had first to create a dataset, because there is currently no existing dataset that distinguishes between technical questions and not technical questions messages in instant communication messages. So first we found the messages from the Node.js chat room in Gitter. We extracted all of the messages that were on the channel. Afterwards, we explored a sample of 1700 messages, and then we identified a set of representative engrams that were found commonly in messages that were technical questions. Using these engrams that we found, we developed an engram filter to filter out the original 9,000 messages based on these engrams, and found a subset of 6,400 potential technical questions. After this, we started a manual labeling effort in which we labeled 1,000 potential technical questions. So for each message, an author will explore the message, read through it, and determine if it is a technical question or not. After inspecting 1,000 messages, we arrived to our ground truth dataset, which contains a total of 359 technical question messages and 631 messages that are not technical questions. Having this dataset, we were able to perform our preliminary study. In our preliminary study, we are dividing the evaluation into 2 parts. The first part will evaluate the classification component, the detection of the questions, and the second one is evaluating the search for answers component. For evaluating the question detection framework, we explored 3 different machine learning classifiers and used hyperparameter tuning with tenfold cross validation using the dataset that we developed on the previous process to evaluate these machine learning classifiers. In particular, we explored the naive-Bayes, stochastic gradient descent, and random forest classifiers, which are very popular in the software engineering machine learning applications. For the second part of the preliminary study, we ran our Gitter ANS framework on 20 random questions that were found to be troubleshooting questions, and manually inspected the results to determine if within the top 3 answers found by the Gitter framework, one or more of those posts answer the question that was originally posted by the developer. In our results for the search for answers framework, we have some mixed results. First, we found that for 11 of the 20 technical questions in our preliminary study, Gitter was not able to provide a Stack Overflow post that properly answered the question within the top 3 results, which were the answer given by our framework. However, for the remaining 9 questions, Gitter was able to recommend a Stack Overflow post answering the question as the first recommendation. As far as the detecting questions component, our experiments showed that the stochastic gradient descent classifier performed the best with an accuracy of 0.78. Now, when we were looking through the results of our search for answer component, we found that for the 51% messages that were Gitter was not able to provide a meaningful Stack Overflow post answering the question, we found that if we removed noise from those messages and leaving only the core question primary information and run the Google custom search on that, we were actually able to get answers to those messages questions in the same manner that we did for the 49% that we actually found answers. So what this tells us is that there is noise in those messages that we need to curate. So this is going to be our future work, is to find a way to automatically remove the noise from these messages that contain technical questions in order to improve the results of the search for answers framework. We also plan to work on improving the classification messages. 0.78 of an accuracy is a good starting point for a classification application, but we want to improve this result to make sure that we do not answer questions that may not be technical questions and provide answers for them, because that will decrease the likelihood of the users adopting the tool. Lastly, we want to also perform a large-scale evaluation of our Gitter. We performed a preliminary study on a small dataset, on a small set of questions. We will want to produce a large-scale evaluation with developers to properly evaluate the usefulness of our framework. We also can see the benefit of using historical results, so questions that have been posted to the channel before, and using those answers that were already found, rather than parsing the message and send them to the Google custom search over and over again to answer the same question. So we'll plan to use the historical results from our framework to decrease that workload. I'm here for any questions. Thank you.
All right, so thank you for the presentation, I guess the recorded presentation. So if there's any questions, please feel free to post them in the chat. Otherwise, I think Esteban is here, so if you can just unmute, and I'll start off the questions because I have a couple of questions for you.
Okay, I'm ready. Hi.
Hi, Esteban. So the first question I have for you was about noise. So you kind of touched about that in the last little part, but you can imagine that for Gitter, this is probably magnified, right? Because you do have a lot of questions, and probably you know, it becomes much harder to decipher noise from real questions. So did you like face that? Did you see that this was particularly a major problem here, or was that just kind of standard? You know, most of the data was clean, most of the questions were clean, you would say?
In our case, most of the questions were actually not clean. So that's what led to the poor results of the tool. When we were inspecting the results, just trying to figure out why the questions were not being retrieved properly, what we found is that the messages tend to be very long, and they tend to have a lot of extraneous information that when you parse into a query, it's not good. So it just tends to throw a lot of bad results to us. So that was the main limitation that we had. There's also noise in the sense that there can be messages that are just very long, very lengthy, and have a format that looks like a question, but it's not a question. Those are also an issue. We didn't found those in our particular data set, but by working in other projects where I've been studying these messages, I've seen that is the case as well there. So that's what we're trying to, in our future work, or current work, is looking through those messages. And right now we're just focusing on, here's a message, there is a question there. So just parse out the noise from that in order to get the results or the answers to that particular question. Another work will be to work on decreasing the noise of questions that are not questions to be detected. But for now, we're just focusing on curating the noise from a message itself. And then we will move on to curating or removing more noise on the more general level.
Okay. And I had maybe just a follow-up question kind of related to this, but I find that with many of these chatbots type of solutions, right, particularly when you're trying to automate or remove manual work that is brought on by just the volume of data, the volume of questions that you have, evaluation is very difficult, right? So I know that you did this evaluation where you tried to say, okay, did I detect the question right? Did I give an answer that was in the top 3 or the top 1 or whatever? But I think there's a much bigger kind of evaluation, which is how much time did I save for people trying to search for these answers, for example, right? Or, I mean, did you have any idea or any plans about how much efforts you actually save, like from a human kind of life point of view, rather than just the technical benefit of that?
We thought about that on the motivation, whether we, like, I honestly didn't consider implementing that into an evaluation, which now that you mention it, I think would be really important to, when we designed our study, to try to assess how much time does a developer spend trying to answer the questions without the bot, and then compare that to with the bot. Yes. So I hadn't, that's the main reason that we wanted to basically develop the bot, is because a lot of these questions will just take time from the developers that could be spent somewhere else. So that's a very important question.
Okay. Okay. I guess I see here one question that popped up. Maybe we have time for one more. So were there any cases where after removing the noise, the tool didn't return valid answers? Meaning, was your noise filtration too aggressive? And if so, why?
In our data set, we didn't, like, all of the questions that after creating the noise, we got valid results, but then our data set is relatively small. So I can see that being the case when we expand it to a larger data set and we start to look at more varied questions.
Okay. Okay. I see a question from Diksha Arya. So do you want to actually unmute and maybe ask the question directly? It's a question about Stack Overflow.
Hello? Yes, sorry. Yeah, it's quite a long question. I actually just wanted to know whether when trying to identify answers on Stack Overflow, because Stack Overflow itself is very free form in the types of text that it could contain. And so the answers also vary in terms of style and often don't focus on one particular answer. It could be an answer to multiple questions from the original post. So did you notice any attributing factors maybe of answers that could also contribute to the noise in retrieving answers? Or were there some aspects, do you think that there's potential for Stack Overflow answers themselves to be sort of filtered out in some way to improve the quality of answers that, or the set of answers that are retrieved?
In our results, we didn't see any type of noise on the Stack Overflow posts, regardless of the variation of the writing style, for instance. But what we did encounter was when you try to retrieve questions from a Stack Overflow, you will also, or very commonly, get duplicate results. And this comes from Stack Overflow having redirection URLs. So you will have that the Google search found 2 different URLs that answer this question, but they are actually the same Stack Overflow post. It's just that the URL has been redirected from someone that asked the question, and then they were like, oh, this question has been answered before. So they redirect to the other post. So in that case, that's the only type of noise that we encounter when we're retrieving the Stack Overflow post. But it has to deal more with the way that the Stack Overflow URLs work rather than with the content of the Stack Overflow posts themselves. But I do think that in future work, we will need to look into that as well.
Yeah, thank you, Esteban. One thing I think that we've done at BotSE is we've kind of started by having this list of papers related to bots. I think what we should do in the future is also maybe have a catalog of data sets related to bots. And I think that will be helpful to many people because, you know, you probably spend quite a bit of time on data sets and you know, if we can share this across people, this will only become more and more of an issue as the community grows. So these can have a serious impact. I see 1 thumbs up from Alexander. So hopefully we'll, that's enough support to 2 thumbs up, 3 thumbs up. So to at least 5 thumbs up to try and put this together. Esteban, thank you so much again.
Thank you.
And a virtual clap here. And we'll move on to the next talk, which is a chatbot framework basically to help with the operations of microservices. Shangpin Ma is here, so he will be able to answer questions after the talk. So please feel free to post your questions in the chat as the talk is going on. Okay, Khalid, it's all yours for the video.
Hello, everyone. Thank you for your interest in my research. I'm Jun Ting from Taiwan, a student from National Taiwan Ocean University. Shangbin is my advisor, and Yuwen is another member of this project. I'm glad to present our research results to you. The paper I'm going to introduce today focuses on a chatbot framework for assisting in the development and operation of microservice-based systems. We call this framework MSABot. MSA means microservice architecture. Nowadays, MSA has become a popular architectural style. The main advantages of MSA include modularization and scalability. In MSA, microservices operate as system components that perform specific tasks and cooperate via lightweight communication mechanisms. However, the development and maintenance of microservice-based systems are more complex than traditional monolithic architecture. Monolithic architecture is relatively simple. All things are put together and follow the same survival rules. On the other hand, every microservice has its own rules. Therefore, the more microservices it has, the more complicated it will be. At present, we use DevOps tools to solve this problem. Let's take a closer look at these microservices. The development of microservices could be divided into 4 phases: requirement analysis, service design, environment establishment, and implementation and testing. In addition to the 4 steps of service functionality, the microservice team needs to set up the development environment that involves multiple tools and track the build status of microservices in the development phase. The maintenance of microservices could be divided into 3 phases: monitoring, detection, and repair. Maintenance engineers need to maintain the build services, monitoring running services, and fix occurred failures in the operation phase. Sounds easy, right? But as long as there are more microservices and various settings, the engineers must spend a lot of time doing these things just like singers. Not to mention that everyone preset may receive this maze. Look back to the monolithic architecture. There are also these stages during development. But due to the simplicity of the system, you don't need to spend a lot of time looking at different service information. There are usually be a master in the monolithic architecture development team who will answer every question about the system. But it's not easy for the microservice architecture to have a master. A person can't understand a vast amount of various information unless he's a bot. Oh yeah, why not bot? So we analyze many cases of using bots to develop or maintain a system to find out this savior, such as that of Hitachi and Kubernetes. However, these solutions are either not designed for microservice systems or only focuses on a single task. For example, only handling version control. Therefore, we propose MSABot to assist in the development of microservice architecture and support natural language processing capabilities. MSABot is based on Spring Boot and combines a variety of microservices development and maintenance tools to allow users to understand the current status of microservices development and operation, and to push the microservice system's real-time error or risk information to users. For the operators who take over the maintenance of microservices, MSABot allows them to understand the overall service architecture and the operation status of each service more quickly. Here are the requirements and tools we have considered. We use Lua, the API gateway, to browse a service information. We apply Actuator to check the usage of a service, and use Swagger browser to read the API documents. We integrate Eureka to see the environmental setting and check the service health status, and use VMAMV, our previous work, to see the service dependency graph for all microservices in a project, and use the above tools to set and view the system parameters. RabbitMQ is the integration channel to get instant messages from Jenkins, Eureka, and VMAMV systems. When a build or deployment on Jenkins is completed, a service error occurs on the Eureka server, or VMAMV produces an error or warning message. The users are notified. MSABot engine is divided into several large modules. HuBot is used to manage several MSABots. In the engine, the initializer is responsible for the initialization. The controller controls the actions of MSABots. The message handler tackles the semantic analysis with the Rasa systems. And the message queue manager handles instant messaging. Rasa is used to understand the intent of a sentence. Rasa can grab or automatically recode the keywords mentioned in the conversation, giving users more flexibility to use MSABot. Similar sentences are allowed to by using Rasa. For the actual deployment and usage, users need to add MSABot into the chat room and set up the URL parameters. Then users can use the MSABot system immediately. Besides, this study invited 11 students, software engineers, and software architects who are familiar with microservices technology to evaluate MSABot. The results shows that more than 19% of the respondents believe MSABot can adequately support the development and maintenance of microservices. 2 of the respondents provided additional feedback for question 4, including 2 kinds of suggestions. One is developer issue. Programmers may prefer the strict command interface and have no confidence in BOT. Our responses is, as mentioned, strict commands are not friendly for users, especially non-programming stakeholders. The second question is context issue. One of the important features of a chatbot is to record the context. It would be better if the chatbot could understand the current situation and may give different responses to different contexts. Our response is at present, MSABot can recall the microservice name mentioned in the previous conversation. Users do not need to enter the service name repeatedly. In the future, we plan to improve the natural language processing capability to understand the context and provide adequate information that the users may be interested in, such as version change log or related test cases and reports. In summary, MSABot provides a flexible conversational interface to extract the service information, service API documentation, building and testing results, the health status, service usage analysis, and service dependency graphs by connecting multiple tools. Users can issue queries to MSABot using normal sentences, not strict commands. Users can also receive real-time deploying notifications and service error or risk messages by MSABot. This is the end of my presentation. Thank you for listening, and I hope you all enjoy my talk. Bye.
Thank you. Okay, so thank you for the talk. I think we all enjoyed it very, very much. This was one of a very dramatic, very intimate talk. So you made a good choice with the student there, Shengpin. The second thing I want to actually say, and I forgot to mention this, is I think you are the latest time zone in the workshop. So that's why we wanted to put you in the first session. What time is it now for you?
Hey, sorry?
What time is it? Like it's like 11 at night.
Oh, okay. Here is 1 a.m.
Yeah. So thank you very much for the dedication. You are the latest time zone in the workshop, but we have to sacrifice you to to reduce the impact on the rest. So thank you for being here. Okay. So I think we had a few questions about the work. I'm going to ask it to you, or Glosia, do you want to unmute and ask your questions? There you go.
Okay,
You're unmuted.
sure. Yes. Thank you, Shengping, for your presentation. I was just curious about which question does the graph, I think on slide 18 answer. What was the question that the graph was answering? I think I missed that. And I also wanted to ask if you say in your future work that you aim to improve your NLP by adding context, if you're already thinking about doing that, or if it's already being done.
Okay. Okay, thank you. I will show my screen to show the. Okay. We have designed these questions to ask the testers to help us to fill in the questionnaires. So we demo our system first and let the tester to communicate with us, and then the testers fill in the questionnaire we design. Okay, so the result is here. Okay, most testers are very agree our system can help them to develop and operate microservices systems. But although they do not actually use our bot, but via our demo, they agree with our results. Okay, it's the first question, answer for the first question. And for the second question, now we apply Rasa framework to realize the natural language features. So the effect of the effect is good so far now. We think if we input questions in English, we can identify correct intents by using Rasa. But we cannot predict what the user wants. So we will plan to design other methods to predict or to analyze the whole project to yield some important information to let the members in the project. We are undergo this feature now. Hope I have answered your questions. Thank you.
Thanks. Thank you very much. Diego, maybe we have one time for one more question. So Diego, you had a question about, or yeah, you should ask it. I'll unmute you. You can ask your question.
Okay. No, I'm just curious, since your audience is also part developers and you showed in one slide, the developers were kind of a bit resistant to use the tool because they are more used to command line tools, right? And me included is sort of how developers go about this. So I'm curious whether you had to do anything in particular in the organization to actually encourage developers to use chatbots as opposed to their familiar, more strict tools, right?
Okay.
Or if anything at all, right? If you had any problems with that.
Okay. How to convince them? Okay. Okay. That's a question I do not seriously consider. But for us, we lack the clear interfaces. For example, if we are using Linux or using Heroku, we will use the clear interfaces. So we believe that the developer like the Chatbot interface because the Chatbot interface like a more friendly, clear interface. And for the non-programming users, non-programming members, they cannot understand how to use the CLI, but using Chatbot, they can input some questions they want, and we will identify their intents. So from the perspective of CLI, we think the MSABot will be beneficial for both developers and the non-programming users.
Thank you.
That's my answer for this question. Thank you.
Okay, thank you very much, Shengpin. And again, thank you for joining so late in your time zone. So much appreciated. Okay, so maybe we will move on to the next talk, just for the sake of time, because I do want to save a little bit of time for discussion at the end of the session. Our next talk is about the very important topic of using conversational bots to onboard newcomers. I will leave it for Khaled to start the video, and we'll please post your questions on the chat if you have any.
Hi, my name is James Dominic. I am a PhD student at Clemson University School of Computing. I work with Dr. Paige Rodagero at the Human Factors Software Engineering Lab. Onboarding is the process of teaching new workers the skill necessary to succeed in their positions and integrate into the workplace. This is often a resource-intensive and multi-staged process. Most organizations invest time and money to make sure that there are proper onboarding processes. It serves as a way to integrate new workers into the environment, both so that they can understand how to succeed in their position, but also to integrate with their coworkers so that they can work effectively as a team. It serves as a way to integrate new workers into the environment, both so that they can understand how to succeed in their position, but also to integrate with their coworkers so that they can work effectively as a team. It is this period during which new programmers become familiar with their project, its source code, and the team, and gain sufficient knowledge. Onboarding to software engineering teams is often very error-prone and costly. Existing literature shows that there are various methods like pair programming which have been used successfully to onboard newcomers to a software engineering team. However, this research do not show how these techniques can be used for remote onboarding. And currently, due to the pandemic, a lot of programmers are onboarding remotely. Open source software uses globally distributed software engineering talent to create high quality software solutions. To become sustainable and to evolve constantly, open source software relies on attracting newcomers and retaining them. However, this is not an easy task. Existing literature shows that the barriers faced by newcomers while onboarding to an open source software system can often lead to them giving up on contributing to the software system. In the recent years, we have seen an increased use of bots to support software engineers in open source software systems. These bots have various functions, from content recommendation systems to bots that can automate repetitive tasks in software development. An example of this is automation of software testing. NNL Rank was a neural network model proposed to recommend projects to newcomers that they were likely to contribute to. We believe that having a bot that can guide a newcomer while onboarding to a project can be beneficial. We also believe that such a bot could positively impact retention of newcomers in an open source software system. The origin of conversational bots go back to 1950 when Alan Turing proposed that machines could think. Advancements in natural language processing and machine learning has enabled human-bot interactions. According Chatbots are being used in specialized domains like education, focusing on student engagement, self-guided learning, course advising, and tutoring. Bots are being used to support social and technical aspects of software engineering. In the recent years, multiple bots have been proposed by various researchers to help with software engineering. Matthijs et al. Proposed a Slack bot to support agile retrospective that could enhance the development process. Urli et al. Proposed a bot that could look for bugs in a system during continuous integration and try to solve them by submitting pull requests. Corizo et al. Proposed a bot that could suggest software artifact experts based on their code repository history. Although the knowledge in this area is growing day by day, The bots available for software engineering are focused on specific aspects of software engineering. Moreover, there is a lack of bots that have conversational aspects to it that could guide a newcomer through a new software system. Onboarding of newcomers to open source software systems is a widely studied topic. In open source software system, onboarding is a difficult task, as well as retaining the newcomer is also equally as difficult. Existing literature suggests that an individual's willingness and the project's environment are key factors in long-term retention of a newcomer in open source software. Fang and Newfield found that initial conditions while participating in an open source software did not correlate with long-term retention. However, situated learning and identity construction behaviors were positively linked to sustained participation. Mentorship is often a big part of onboarding a newcomer to a software development team. However, it's not always easy to offer mentorship on an open source software system. Canfora et al. Proposed a recommendation system where the recommendation system would suggest existing contributors who have contributed to the same topic which the newcomer is working on. Onboarding and long-term retention of newcomers to open source software systems still remains a challenge. We propose a conversational bot system that could help newcomers with finding new open source projects to contribute with, as well as guide them through the contribution, each step of the contribution they make to the open source software system. This bot will be able to communicate with the user via a conversational interface where the user will be able to talk to the bot and the bot will be able to talk back using natural language processing and other machine learning techniques. Here we look at the workflow of the bot. When a newcomer joins an open source community, the bot will collect the newcomer's experience, interest, and preferred languages. This information will be used by the bot to create a list of open source projects the user might find interesting to contribute to. Once the newcomer selects a project to work on, the bot will also suggest the issues the user might be able to work on based on self-reported previous interests and experiences. Now the newcomer selects an issue to work on. From here, there are 3 different workflows the bot can choose. At this point, the bot will go into an idle state and wait in the idle state for a fixed amount of time or until it's invoked by the newcomer. So the bot will wait for a fixed amount of time and check in with the newcomer if the bot did not hear back from the newcomer. If the newcomer is still working on the issue and is not requesting any help, the bot will go back to its idle state. If the newcomer requests for help, the bot will scan Stack Overflow and give the newcomer relevant information which might help the newcomer to solve the bug. The bot will then go back to an idle state. The bot will wait in that idle state for a fixed amount of time and check back with the newcomer, and if the newcomer does request for help, the bot will connect the newcomer with an experienced contributor on the project. If the newcomer can ask for help at any point of time, and the bot will provide the newcomer with Stack Overflow content which would help the newcomer in solving the bug. If the newcomer's pull request is successful, the bot will congratulate the newcomer and collect feedback from the newcomer on the experience. The bot will then suggest new projects or issues the newcomer might be interested in working on. In order to develop this conversational board, we plan on using Rasa open source, which is an open source framework for building conversational boards. It is capable of facilitating natural language understanding, which is needed to interact with the newcomer. GitHub's REST API allows us to access the newcomer's public profile as well as projects on GitHub. We plan on using Stack Exchange API to get access to Stack Overflow content. This board could be integrated with a collaboration software like Slack, thus eliminating the need to develop an interface. Our research, however, has some limitations. We have developed a dialogue corpus which includes conversations between 40 new developers in a software system who are collaborating during pair programming to solve bugs in the system. We feel that the dialogue corpus which we have is too small to develop a meaningful neural network system. Even though increasing data in the dialogue corpus is expensive and time consuming, we feel that we should continue adding more data into the dialogue corpus. This paper proposes a new conversational board for open source software systems, which can guide a newcomer throughout the onboarding process and help retain the newcomer to make future contributions. We introduced the systems prototype for developing a conversational bot for the same purpose. We provided the steps we believe are necessary for the development of the bot. We believe that this type of a board would increase future retention of newcomers in open source software. Thank you.
All right, so thank you. And I think we have James here. And I know we have Paige as well. So we at least have a couple of the authors, and Igor I saw earlier as well. So, so thank you, James. So I will, I think that there's some questions that came in. If not, I also have a few questions for you, but more about the future. So one question I guess came in from Ahmed. Ahmed, do you want to unmute and ask your question?
Okay, first, thank you for the nice talk. My question here is, so one of the research limitation is the size of the training for the Rasa platform. So I'm wondering, how are you planning to overcome this challenge by collecting more clear data set that will help to improve the accuracy of the bot?
Yeah, thank you for that question. That's an excellent question. That is still a challenge which we are facing to date. We do have a dialogue corpus, but it's pretty small. We have added some data to the dialogue corpus after the paper was published. However, we are still on the lookout for good data sets that could be trained. And we have done some work on it. So we have done some work on the data part of things, and we are currently working on getting a paper out of that on that side. Yeah, so you will be able to read more about it once we get the paper out. Thank you.
Okay, thanks. So the next question came from Neil. So maybe Neil, you can unmute and ask your question. There we go.
You always say unmute yourself, and then I realize that Emad actually has complete control.
It is my evil plan.
Yeah, thanks for the interesting talk. I guess this is a question for you, but I think also maybe broader for the community, which is how you test what the bot is saying. So you could clearly have some gold set and say yes or no, this is what we want it to say. But for this type of thing, for example, do you plan to have some kind of study that will ask people, like, well, did you like the bot experience? Did it recommend what you had hoped it would recommend? Right, so I think this question of testing what it's doing is a little unclear to me, at least.
Yes, we will have to conduct a study. We will have to design an extensive study to test the effectiveness of the bot. And I also think that it is very important to do a qualitative study than a quantitative study, because it's more important to give relevant information in a context which is better than the information which we find out there on Stack Overflow or just Google. We should be able to give better information than that through the bot than just giving them Stack Overflow links. So yeah, it's something which is on our mind. Yeah, once the bot is developed, we will definitely conduct a study and evaluate this. And I believe it should be more of it should at least be a mix of qualitative and quantitative approaches, because we need to measure productivity. We need to measure if we have increased retention, because that's one of the challenging parts of open source software, as far as I understand, that it's hard to retain contributors. So that part, maybe we could measure it quantitatively, but the bot interaction itself is more of a quantitative aspect. Yeah, thank you for the question, and I'm really interested in knowing more of your thoughts about it.
Thank you.
Okay, thanks. And the next most highly voted question is the question from Philippe. So Philippe.
Yeah, so I guess my question is mainly, do you see a danger when you deploy a bot to help newcomers in a project? Do you see a danger that this actually backfires and people feel like, okay, now they can't even bother to help me themselves?
So,
do you see a social issue there potentially?
That's a very interesting topic, right? Like anything related to bots has to be, I guess, dealt with caution, because we don't know the full impacts of it until we implement it and let it out in the wild. So as of now, GitHub already has a mini version of this bot, which helps newcomers select a project which they might be interested in contributing to. So I think we can look at it at two different ways, right? So we can always look at it as, or maybe we should look at both ways. Like, we should look at how it can help, and we should also look at how a bot might really hurt something like an onboarding or retention or even productivity, interactions, socialization, and all those kind of stuff which happens in a normal software engineering team. So yeah, I think we should look at both sides, like how can this help? And at the same time, how can this bot minimize any kind of negative side effects, or like undesirable side effects, which one of which could be like people might just not interact with each other. But the bot also has a function where it connects a newcomer with an experienced developer. So maybe that might offset it, maybe not. But yeah, it's something which really needs a lot more research once we have bots which are truly capable of helping newcomers onboard to open source software.
I think the bot is sort of a mediator between the existing experts and the newcomer might be the most promising angle here. Not kind of replacing the onboarding, but kind of reducing the friction in the process.
Yep. So, and again, adding on to that, like a lot of newcomers need, I mean, this might be more anecdotal, but a lot of newcomers do not go and ask questions to experts just because they don't want to bother them or are afraid to go and ask questions. A bot like this could really help in that part, but also could help connect newcomers with experts, yeah, I agree with you.
Good.
Okay, thank you. So we have a couple of things. So what we'll do now is we'll open it up for the discussion, and then we'll have the 10-minute break, and then we'll start the second session with the keynote from Gregor. Just before we open it up for the discussion, I would like to do something at the end of the discussion, just before we head out to the break, is I would like everyone, if possible, to turn on your camera and set your background to your flag of either the country you belong to, you reside in, or the one that you love. So you can see Stefan. I prepared him for this already. So Stefan is leading by example. We would like to take some sort of workshop photo just before we head out to the break. So we'll take some screenshots and we'll tweet them out, and that way you can represent your place of living or residence or whatever, nationality. Good. So so let's open it up for the discussion real quick. So I think that there's three or four things that kind of came up that emerged from the presentations and the keynote that were done earlier in the day. The first one was the difficulty, I think, of testing bots, and I think that this is an area that is largely unexplored. Jordi touched on this, and I think it might be a good idea for us as a community to have just even a quick discussion about that. The second one is the role of NLP, and I think more than one talk touched on this, that at least for chatbots, NLP is huge, right? And understanding the questions, even presenting the answers to our users or the people who are asking questions can be a tricky thing to handle. And the last point that I want to kind of open up is also about human studies. So we have a lot of bots, we do a lot of evaluations, but it seems like in many cases what we're trying to help is we're trying to help people. But these human studies are difficult, right? And so how do we handle that? How do we want to handle that? Should we have, as a community, a collective effort to handle that? So I just want to open that up. If you want to speak, please raise your hand or feel free to just message in the chat, and I can give you the mic. So maybe I'll start, or does anybody else? Do we have any volunteers to start? Going once, going twice. Okay, so maybe I'll start. And I want to maybe this is a question that I have for Jordi about testing bots. So clearly, you mentioned that this is a non-trivial issue and this is something that you have to deal with. How do you deal with it so far? I mean, even in a primitive sense, how do you deal with it? Is it just kind of like throw it out there and hope for the best, or?
Sorry, I was busy looking for the Catalan flag somewhere. For the testing, as I said, right? So there are, as usual, the different types of tests. For very simple tests to make sure that the bot responds what is supposed to respond when the user input is the expected one. You have tools like Botium that again work like Selenium. So that covers the basics, and this even allows to perform regression testing, right? So to make sure that if you add more training sentences or intents to the bot, the previous test cases still work as expected. So that, I think that's a minimum. After that, it gets much more complex. If you really want to test how users feel with the bot and whether they are satisfied or not, I think that you need to either to add to the end state of the bot quick survey or just a poll or say, okay, were you happy with interaction with the bot? If the bot has an end in the conversation, so if the conversation are really kind of a sequence of conversations, so that could be an option. Otherwise, you can look at the abandon rate of the bots, same as you have this all these abandon rate plugins for e-commerce. So same for the bot. So if you expect the bot to follow a 10-step conversation, and then by looking at the monitoring data, you realize that only 5% of the people reach the end of the conversation, that's another way to absolutely know for sure that something is wrong with the bot. So I think you need to resort to these more clues because there's not really any other way to really ask the users.
So maybe another thing that I noticed as talks were going on is that a lot of these bot frameworks have 1,000 technologies, right? And 1,000 even different technologies that can be integrated together, right? So you have this somehow all this integration issues, right? Did you do anything to manage those specific? I mean, I know at the end you can kind of look at the conversations, but in between, are there any steps that you follow in between?
We do have some tests of the integration between, for instance, the Slack and or bot platforms, things like that. But that's more standard testing, right? Because this is still at the level of API calls between the different platforms. So that's not so complicated. I think that the really complex part is the NLP part. Again, because you probably depend also on third-party providers like Dialogflow that they can change at any time. So here, I think that there's a lot of interesting work. Also, as I said before in the presentation, about the generation of these test cases from the bot definition, right? You could use dictionaries to basically make sure that the bot recognizes variations of the training data, paraphrasing, things like that. So to get really a much more testing before actually releasing the bot.
Okay. I see that Theo had his hand up, I believe. Theo Zimmerman, so do you want to speak? I can unmute you. There you go.
Hey, sorry, I raised my hand by accident and didn't notice, so I didn't have any part in the
I was scratching my hair excuse that we get in class now, right? Because we're virtual. Just kidding, but yeah, totally fine.
And I'm also not finding how to set my background, so sorry about that, but
okay, so you go to the video where there's the little arrow at the bottom and you will say choose virtual background, but I think it depends on your computer. So
so maybe this is my version of Zoom not supporting that.
And I think it's also a setting in Zoom that you have to allow virtual backgrounds, and then there you have to go set it. Okay. But sometimes I know that if your computer is old, Zoom doesn't allow you to do that.
Possibly.
Okay. Other questions I see here. One was posted, so we have not tested. So I guess this is from Dominic or from James. Sorry, saying that they did not. Did you want to chime in here, James?
Oh, I was just responding to one question by Mahdi. I was just responding to the question, that's all. And my response was, we have not tested the bot yet. We are in the process of understanding the requirements in detail. And once we have the bot, we will test it.
So one thing I wanted to say about that, actually, that's kind of one of the comments that one of the questions from Mehdi is the question that kind of led me to put human studies and evaluation, right? Like, you know, when you do bots like the one that you've put together, right, about onboarding newcomers, well, that's not so straightforward as an evaluation. You know, the evaluation of that is not so straightforward. I mean, human participants, there's like, you know, you got to follow them for a specific amount of time and all these things. And I think you're not the only one. I think a lot of these bot frameworks, as we become more complex and more closer to the human side of it, we will have, you know, these will be questions that are raised. I don't know if anybody else wants to chime in on this, what they've done, how they've done it.
I think one thing is that with the onboarding, we can use students to test, and I'm not a big fan of using students to evaluate, you know, something like a bot personally, but for onboarding, they are onboarding, they're new to projects like seniors or grad students, so I think that's something really nice. But it's really difficult to recruit these professional programmers. At least for us, it's been very difficult. I didn't go. I sent James and a bunch of other students to Atlanta for a week and had to get a hotel room and office space just to do a study and get results last summer. So it's been really hard for us to collect that kind of data.
Wow. Yeah, I mean, yeah, who else?
I'm Mehdi. And we have studies that analyze and measure the contributor abandonment in the projects, like studies Eleni suggested about past factor. They analyze and measure the contributor abandonment. So we can use these metrics to analyze contributor abandonment after onboarding them.
If I may chip in here,
Yes.
the difficult thing though is to know why they left. So was it because they didn't have support from the board, or it's, I mean, that I think only qualitative studies can show. So go and ask people.
So right now we're doing some work with the newcomers to open source and trying to see what do they actually need, because I think that's really important for our bot for us to build to better understand rather than just throwing a bunch of stuff in. But yeah, it's really hard. I think what we're seeing is it's hard for newcomers to even just get to that first commit, and so they just get stuck and give up, is what I've learned so far and through the related work. But we're still exploring this, and I think that's a really good point, is like what is that breaking point for them?
Yeah, I also wanted to add that, so I do understand the complexity of what I'm proposing, and yeah, I mean, I really appreciate all of you chiming in and letting me know, because yeah, it is really complex. Once we started working on understanding what questions do newcomers ask, or what are the challenges they face, that's when we knew more about what are the challenges in building a bot that could truly help a newcomer onboard to an open source system.
So one thing I will say that we've done in our studies in the past, and we've somehow won, is we've argued with journal reviewers that using students was actually the right thing to do when using bots, because we had access to them, right? So in many cases, when you try to reach out to professional developers, it's very hard to do follow-ups with them, for example, right? And with bot type of studies, you always need to do these kind of follow-ups or understand why they said how they're using what what you've developed. And I think reviewers have understood that, and I think that's critical, because we are the community for that. So if we are supportive, if we agree that this is something that we should do, then we shouldn't let anybody else tell us otherwise, right? So I think this is just one way to alleviate this issue of human evaluation, because it is something that is impacted more, like the bot community is impacted more by than, if you're building, just a biased example, if you're building like an analytics based of type of dashboard or something like that, and you're trying to evaluate, accuracy.
Yeah, I agree with you. Like, we need a lot of follow-ups, and it's really hard to do with professional programmers, and students, I think, are the best to do such a study.
Yeah, I mean, at least, if you can get access to professional programs, great. But if you can't, I don't think you should be penalized, right? That's how I see it, as long as it makes sense and it fits the case. Maybe I will ask, just because I know that Gregor works a lot with, Probot, and you guys create a lot of these actions and bots on GitHub. So do you have any input on that, Gregor, or have you had any experience with that?
Testing is hard with bots, both like automatic tests and tests with people. I didn't run into a case where we actually wanted to make, like a field experiment and have people test the app and do follow-ups myself. I'm not aware of such a case, but I can confirm that it is not easy.
Okay. And you even do that even for the widely popular bots as well? Like you kind of just create them, they become popular, they survive, or if they don't become popular, they don't survive, kind of thing?
Yeah, exactly. I mean, they're out there and people tweet about them or share them, and then they grow in popularity. And most of the most popular bots are open source themselves, so people can start engaging through GitHub and through GitHub issues and pull requests that way, and can let us know what works and what does not. So it's not a perfect scientific environment for testing, but we get a feel, like a subjective feel of what are the pain points, what we can improve, and what are good ideas to, build upon the bot and make it better.
Okay. Yeah, I mean, I think that's a strategy that we can potentially use. You can just put bots out there and say, like, look, I have 1,000 users for my bot, right? Who are you to say that it's not good or whatever as a reviewer? I think that's a very valid strategy as well. Potentially something we can do more of in academia. Neil, did you have your hand up? Did you want to say something? Or?
I guess my only comment would be, it'd be interesting to have some kind of protocol that came out of like Paige's work, for example, you know, here's the things that work well for testing, or from your work, Emma, that said, you know, don't do interviews, or, you know, do something differently to help the community understand what a valid bot approach would be, and what are the standards that we should be using to do either research review or, you know, commercial review.
I really like that, because I've run into the problem of having papers rejected for using students in the past, and it'd be nice if the community all like had either some guidelines or some type of documentation of how like we should go about this kind of testing. I really like that.
Okay, I think, yeah, we can definitely at least try to facilitate that through the BotSE community, right? Okay, I was told that we're over on time. We're short on time, so everybody put your game face on, put your flag on, because I guess Glacia, you'll take the screenshots, or Khaled, you'll take the screenshots. This is looking pretty great so far. So please, you know, I'm going to say it once, say it twice. If you want, please turn on your camera. Put your countries of residence flag, whatever you relate to, put a flag. And I guess Khaled, let me know when you're ready, and I can just announce it to everybody.
I am ready. Whenever you guys, whenever you say go, I'll take the snapshot. But we'll have to take 2 snapshots. There's too many for me to take in once.
Yeah,
So,
I think you'll have to take probably. I see 4 screens, so we might need to take.
for me, it's 2. Yeah, I have a large screen, so yeah, it's 2.
Yeah.
2 takes.
All right, you count it down. It's all yours.
Okay, so 1, 2, 3. All smile. Okay, so that's 1 snapshot. And now for another one. 1, 2, 3, all smile. Okay.
We're good.
That should be it. Yeah. Yeah.
Okay, super. Tweet it and add the Twitter handle of everybody in these screenshots, please. Just kidding. Just mention the BotSE hashtag, and then people can retweet it to represent their country. All right, so I will hand it over to Stefan from here, who will tell us how long our break is and when do we start the next session.
Yeah, so Iman took everything quite over time, but I guess we need a break. So I guess we take our 10-minute break, and we'll start in exactly 10 minutes with the keynote of Gregor. And we're having Gregor Martinez here, who works on Probot, a bot framework, open source framework in Node.js for GitHub apps. And he's been with GitHub for close to 10 years and software engineer for more than 20 years overall. And he will give us some ideas, some insights into how to automate GitHub workflows with Probot. We are very much looking forward to your talk, Gregor. Please go ahead.
All right. So yeah, danke, Stefan, for the kind introduction. And thank you, Marielle and Marco, for inviting me for giving the keynote for the Bot or Not track today. I'm personally very fascinated with all your research on bots. I missed the talks this morning because I'm just too nervous in front of my own talk, but I will watch the recordings. And as an engineer building these bots and helping everyone else to build these bots every day, I do hope to give you some insights that will help you with your future studies. I will talk today about what GitHub bots are, how GitHub bots work, and how you can create them yourself using Probot, the GitHub app framework for Node.js. So let's jump right in and create the Hello World version of a GitHub bot. It comments on all new issues in a GitHub repository. The code editor you see here is on glitch.com, which is both an editor and a runtime environment for Node.js applications. And every time I change code, it restarts the app, which is great for demo purposes, such as this. The code you see is the entire code for the Hello World bot. The two important parts are that it acts on the issues open event, and then it creates a comment. I can remix this app, which creates an own copy for me. So this is an entirely new app, and I can show it directly in the sidebar, which gives me this register GitHub app button where I enter the name for my app. I install it on my repository. And then when I create a new issue on that repository, I get a comment from my new bot. And that's all that's to it. So thank you so much for coming to my talk. And do you have any questions? Okay, no. What just happened? Let's take it slow. Let me walk you through the 3 steps that it takes to create a GitHub bot and adding it to your repositories on the example of this Hello World bot. So first, you have to create your application. That's what I just did on glitch.com. The website you see on the right of the sidebar is the UI you see when you open the app's website. The app's URL must be accessible to GitHub in order for GitHub to be able to send the event requests to your application. And each app on glitch.com has automatically a unique URL, so that is very easy. Next, you have to register the application you coded with github.com. When you start your app that you've built with Probot, it will recognize that your app is not yet configured. And without configuration, it cannot receive and verify event webhook requests from GitHub, and it cannot authenticate your requests towards the GitHub API. So when configuration is missing, Probot shows you this register GitHub app button when you open the app's URL. And when you press it, you will get redirected to github.com. At this point, if you are not signed in yet, you will be asked to authenticate with your user account. Then you provide a name for your new app that you want to register with GitHub. And it also, besides the name, passes on a lot of information automatically that you don't see. For example, it passes the permissions that your app requires. In our case, I need the permission to create a new comment. And it also needs to subscribe to events. In my case, I want to be notified whenever a new issue was opened. And I need to upload a URL that GitHub can submit its event webhooks to, which is the webhook URL. In return, GitHub will provide me an app ID for identification, a private key for authenticating the requests I send to GitHub, and a webhook secret, again, for verifying the events coming from GitHub. This is what the app registration looks like when you created a bot on GitHub, when you create a registration for your bot on github.com. You see the app ID 70830, and at the bottom of the screen, you see the name for my BotSE Hello World bot. On the permissions page, you see all available permissions and that my app has read and write access to the issue permissions. And at the bottom, you can see all the events that are accessible to my application based on the permissions. And that in my case, I am only subscribed to one event, the issues event. There are a lot of permissions that your app can request, much more that is available for user-based authentications using OAuth scopes. And there are even more events. And nearly every one of these events you see here has sub-events, so-called event actions. And in the case of issues, the actions are opened and edited, deleted, pinned, unpinned, closed, reopened, assigned, unassigned, labeled, unlabeled, locked, unlocked, transferred, milestones, demilestones. And new events and actions are added all the time as new features are added to github.com. Now the question is, how did my Probot app know which permission it actually requires and which events it subscribes to? When we go back to the editor on the left side, you see besides the index.js an app YAML file. And this app YAML file is exactly what this is configured. You see the events I'm subscribed to, issues, and the default permissions, issues with write access. After the registration is complete, Probot stores the app ID, the private key, and the webhook secret in a .env file to basically self-configure itself. Again, the app ID is to identify my app if it sends requests to the GitHub API, and the private key is to create a JSON web token to verify my request towards GitHub. And the webhook secret is when I receive requests from GitHub to verify that they indeed are coming from GitHub and not a malicious third party. And once your application is configured, then the register GitHub app button will disappear from your app and it's ready to be used. So after creating the app, registering it on github.com and configuring using the app ID, private key, and webhook secret, the app is ready to be installed on the repository. So you can select it. You can select your own user account or any organization that you have access to, and you can install an application on all current and future repositories or on selected repositories. In my case, I installed it only on the Sandbox repository. It is important to understand what installing means here. It's not the same as installing an app on Windows or macOS or your phone. For GitHub apps, installing means that you give access, you grant access to the permissions of that the app requested to all your repositories or selected repositories. Without installing an app on your repositories, it cannot do anything. But once the app is installed, then my app will start receiving the configured issue requests, and it can act on it and verify the request towards GitHub. So it can create a new comment using the app ID and the private key. All right, let's recap. First, you create your app, which is basically a server with an accessible URL. Then you register your app on github.com by providing the name, the server URL, the permissions your app requires, as well as the events it wants to subscribe to. And in return, you receive the app ID for identifying, the app key for authenticating outbound requests, and the webhook secret for verifying inbound requests. Finally, when users install your registered app, they grant access to repositories on their GitHub user account or any GitHub organization that they maintain. Once they installed, the bot request workflow looks like this. First, on github.com, the user creates a new issue. Then GitHub creates an event payload for this issue opened event. It uses the webhook signature, the webhook secret to create a signature based on this payload, and then post it as a request to my application, sending the signature as an HTTP header. Then my app verifies the signature, and it sends a request back to GitHub to request an installation access token with its app ID and private key. Then GitHub verifies that request using the same app ID and private key and responds with an installation access token. With that installation access token, my app can now access the repository it was installed on. So you can send a request to create a comment, and then GitHub verifies the request with the installation access token, and the comment gets created. So I hope that you have a general understanding now of how most GitHub bots are being built today and how they work. But like with all demos, of course, I only showed you the fun parts. The truth is that there is a lot of friction when building GitHub bots that way. So let's talk about friction. Here is an incomplete list of pain points that probably all of you already run into, or you will run into once you start building your own bots for your studies. And I will talk about them later on in my talk. One friction is registration, especially the registration of an existing application. For example, if you want to run your own instance, or you want to build your own app based on an existing app. And my first demo showed that Probot helps greatly with that, so you don't have to go manually through the GitHub app registration process. Instead, you have this webflow where you just need to enter the name and that's it. There's other friction that Probot can help with today, but it can only go so far. Some of this friction it can only help with partly, and some of these frictions Probot cannot help because it's just a limitation of GitHub's APIs today. One particular friction that the Probot team focuses on is local development, because building and iterating on new and existing bots from your local development will make you so much more productive. And I will show you another demo where I will create a bot entirely from scratch. And besides showing how local development works, I will also show you another friction, which is feature discovery. So this time I will build CI-bot, which will prevent merging pull requests that are still being worked on. So in my terminal, I create a new temporary folder and initiate a Node.js project in that folder. And then I create the index.js and app.yaml file. Then I install the Probot as a production dependency. And I install the SME client library as a development dependency. SME is what enables me working on and running my bot locally, although GitHub cannot directly reach it. And I will talk about SME shortly. So next I added the app.yaml file to list the events I want my app to subscribe to, as well as the permissions that it requires in order to work. So it needs to be notified about pull request events, and it needs read access for pull requests, so it can read the title. And it needs write access to statuses, so you can set a status for pull requests. I also need to define a URL because that is required by the GitHub API. That is the homepage URL. Next, I create the code for my CI bot. And here is where we hit the other friction I mentioned, which is feature discoverability. There are over 100 events and event actions an app can subscribe to, and over 600 API endpoints your app can talk to and interact with. And nobody can remember them all. But luckily, Probot exposes TypeScript definitions, which you can load even if you are building your app in JavaScript. Now you see you get a type ahead for all the events and event actions. You also get a type ahead, so you don't need to guess what the property is to get the pull request title. It is on context payload and then pull request title. You also don't need to guess what the method is called to create the status, because you get the type ahead again. And not only for the methods, but also for the properties, you get type ahead. So you don't need to guess whether it's state or status, and you don't need to guess what other properties are required. For example, the SHA. And again, you don't need to guess what the property is in the event payload where the SHA is set. And then I set the description and context properties, which is the text that will show up in the GitHub UI in the statuses list. And that is the whole source code for this little bot. So once I'm done with the code, I have to configure how to start it in my package.json. So in this case, I have to use the Probot binary with the run command and then just set the path to where my source code lives for my app. Now I can start my Probot app, which will start the server at localhost 3000, and it will show the same register GitHub app button that I've shown you in my first demo, where again, I can just set a name and then install the bat after my registration on my repositories. Now that my app is fully set up, I can add or remove the WIP from a pull request title in order to set the status from my CI bot to success or to pending. So that's all that my little bot does today. So how does this work? How is this even possible? Let's talk about SME. SME.io is a website, and you can think of it as a proxy. You can set the webhook URL in your GitHub app registration to a SME channel URL, and SME will then receive the webhook request from GitHub and emit server-side events, which is the W3C standard to continuously stream data, similar to WebSockets, but server-side events are only one way. So when you create a new channel on SME.io, you get this randomized URL, and this is what you then can pass on to your GitHub app registration. Probot does that automatically for you, so you don't need to do it. And it directly passes this SME URL when you click the Register with GitHub button. So when I start my CI-bot locally, the SME URL is logged, so I can open it in my browser. And when I go back to my pull request, and set the status to pending and back to success, I can now go back to SME and I see these pull request events being here. And I can not only see the full events and their payloads, I can also resend them. So here, I could test my bot if it actually works without going in and create a new pull request and changing a title and changing it again. I can just resend the existing events using SME, which is very helpful for debugging. And that concludes my demo about reducing friction for feature discovery and local development. Compared to the event request flow that I've shown you today before, when you run your app locally, it's only slightly different. Instead of GitHub posting their event payload directly to your app, like before to Glitch, it now posts its events to SME.io channel that you configured. Then SME.io receives that events and emits a server-side event. And the Probot app then pulls this data from SME.io, and then you can verify it and handle the event. Everything else is basically the same. All right, so let's talk some more about friction. One thing that you probably heard of in regard of GitHub is there are GitHub Actions now. GitHub Action is great because you don't need to run your own application. You don't need Glitch or another runtime environment because GitHub will run your code for you, and it can act on the very same events and event actions that GitHub apps can act on. The disadvantages is that basically by installing a GitHub action, you have to create a .yaml file in the repository. So you cannot install a bot globally on an entire organization. You always have to create these YAML files, and you have to keep them in sync to update things. Another advantage for actions is that they have secrets, for example, which apps do not. But another downside is that, for example, my work in progress CI bot acts immediately because my app is already running. So you can directly see the changes in the GitHub UI. While actions will need some time to boot it up. So it will take 30 seconds to 1 minute to just update the status in the UI. Another common friction is bootstrapping. So when you think again about my work in progress CI bot and you install it on your organization, right now it only acts on newly created pull requests. It does nothing with existing pull requests. So what you might want to do is upon installation, you want to load all the repositories, then you want to load all open pull requests, then you want to check all these pull requests and decide whether you want to set a pending status or not. Like Probot is not helping a lot with that. You have to worry about that yourself. Caching is something that Probot helps with, not any kind of caching, for example, not with conditional requests, but it does cache the installation access tokens that I've been talking about. Because these installation access tokens, they are valid for 1 hour, so it does not make sense to recreate them each time your app receives an event from GitHub. So what Probot does is when it receives an event for an installation, it checks if it has a cached installation access token in memory and it uses that instead. The problem with recreating these installation access tokens all the time is that you will run out of your rate limit very quickly and your bot will stop to work. CI, continuous integration, is a very big challenge. Ideally, you could run in your pull requests automated tests that spawn up a new instance of your application, but there is no way to programmatically create a registration on github.com. So it is manual that you have to create a new GitHub app registration and then configure the instance that was spawned for your pull request on github.com. I wish this would be able to automate, but it's not possible today. Configuring your Probot application is something that Probot helps you with. It's not something that GitHub provides you out of the box, but with Probot you can create .yaml files in .github folders. For example, for the work in progress CI bot, you could allow the users to configure the terms that the bot is looking for. Instead of just WIP, it could look for do not merge or like a construction emoji. Then data persistence is something that many GitHub app developers are asking for, but it's not something that GitHub provides. You cannot store your data with GitHub directly. We are thinking with Probot to create some abstraction APIs and then create backends for things like Redis or MongoDB or CouchDB or SQL, but it's not something that we did so far. Running your Probot app against GitHub Enterprise is fairly simple. You just need to define the GitHub Enterprise URL and everything else will work. It also handles some of the differences between the APIs of github.com and GitHub Enterprise Server, so you don't need to worry about most of it. Error handling or exception handling is also something that Probot helps you with. If there's an exception and something goes wrong, ideally you want to send an error to a third-party service like Sentry.io. And with Probot, you just need to define the Sentry DSN in an environment variable, and it will just work out of the box, and you don't need to add any other code. I already talked about feature discovery and local development. Marketplace is a place, github.com/marketplace, where you can have your bot listed, which helps with discoverability. So this is how you may find additional users for your studies. It also allows you to define plans, so people can pay to use your app. But the problem is that it's totally up to you to find out if an event that you receive from GitHub is coming from an installation which has a plan or not. And unfortunately, Probot also does not help with that. Monitoring is another problem because sometimes these bots just stop working, right? Because your server is down. And right now, there is no way for users to find out what's going on. They just realize, like, where is the status from the work in progress CI bot? And there is no place where they could get notified telling them that the CI bot is down right now. Rate limits. This happens when you send too many requests at once, then GitHub will just block you and your bot will stop working. And Probot puts some logic in place that throttle your requests, so you don't send too many at once, and you adhere to the recommendation, to the best practices that GitHub recommends in the documentation automatically. Registration we already talked about. New permissions is also a very interesting case you have to keep in mind. Now that people installed my work in progress CI bot, I cannot just go in and change my registration and request new permissions. For all existing installations, I cannot just ask for permissions to, let's say, create new issues. If I would ask that, then every user with existing installations would get an email asking them to accept the new permissions. And until they accept the new permissions, my app has to work with both the previous permissions and the new permissions. So the code complexity of these bots become bigger the more often you go through the process of requesting new permissions. So better ask for more than for less and be thoughtful about what you might need in future and just add it right away. Secret, as I mentioned, there are no secrets for GitHub apps that you can have your users store on github.com, unfortunately. You would need data persistence and figure it out yourself. And staging is similar to CI, maybe a little simpler because you can have one additional GitHub app registration specifically for staging, but it's still not very easy to do. Statistics is well, I wish you could just go to github.com and find out how many users you actually have with your bot, and you can't. And the app The APIs are also not as simple to find out, for example, how many installations you have and how many repositories in the installations you have. You need to do all that by yourself, unfortunately. And lastly, testing is also not straightforward. Right now, everyone figures it out how to test these kind of bots. It's fairly hard to mock these event requests and then mock what your app will send us requests and the responses it will retrieve. But it is also something that we want to improve with Probot. So in the next 2 sessions, Tapachit and Mehdi will talk about their studies on commits created by bots as well as detecting bots. And I've made a third bot which touches both those topics, just to give you some context for the talks from the other side. I created an app called Update Authors, which already exists, and all it does is it basically adds new contributors to an authors file in the repository. So you can just go to github.com apps, update authors, and install the application on your repository. And once it's installed, when you merge a pull request from a user account, the update authors bot will create a new pull request. And there it is. And in this pull request, it will either create or update an existing authors file. Like in this case, it updates the authors file and adds gr2m as a new contributor. Now, when I merge this pull request, I ideally don't want to get another pull request adding update authors to my authors file because it's a bot, right? And ideally, this would work for any kind of bot. So the code for this is 30 lines of code roughly, and it uses a create pull request method from an external library. It acts on the pull request closed event. It checks if the pull request was merged. If not, it just ignores it. And then you see I check whether the current author is a bot or not. And this, of course, is a very naive check. And a method based on the research by Mehdi's team would be much more successful to identify bot accounts here. And with that, would just make this bot much more useful. Finally, the create pull request method creates a new branch and checks if the authors file exists and creates it, or otherwise updates it with a new commit, and unless the current user is already listed. And finally, it creates a pull request for the new branch containing the new commit. So there are a lot of requests going on, but it's all abstracted away in this single compose create pull request method. And I hope that gave you some insights and some context of how the type of bots work that the teams by Mehdi and Tapachit researched. All right, that's all I got today. Thank you so much for watching, and I'm looking forward to all your questions.
Thank you very much. Great talk and cool demo. I think it's impressive what you can do with so little code. I've seen a couple of questions on the chat. And I think Neil was the first one. Do you want to ask your question, Neil?
Yeah, thanks for a really interesting talk. I guess my question is more of just a point of curiosity, which is what is the most interesting sort of application you've seen of Probot?
That is very good. You know, like personally, I like bots that do not necessarily work with code. I really like bots that work in other contexts and, for example, help to onboard new contributors or help editorial contributors. For example, I've built a bot that lets you use a GitHub repository as a backend for Twitter. Like a lot of bigger projects have Twitter accounts and, you know, the maintainers have access to it, but nobody's tweeting because nobody wants to upset others. So you can submit a pull request to this, you know, Twitter repository with a tweet text file, and when it gets merged, then the bot automatically tweets it out. So you have a review process. Another bot that I really like is called First Timers Only, that lets you create very, very great issues to onboard people who are entirely new to open source. And instead of, for example, let's say you find a typo in your README, and instead of fixing it right there and have it done, you create a branch which just starts with first timers and then something, and then this bot will pick it up and create a very extensive issue with a lot of instructions of like, how do I contribute to this, and what is the change I need to do, what are the buttons that I need to click. So it doesn't cost me more time as a maintainer, but it helps to onboard new people to open source and to my open source projects.
That's really cool. I wonder if, is there like a Hall of Fame on the Probot site?
Yeah, probot.github.io/apps. We have some apps listed there, and I think both these apps are listed there.
Okay, thanks.
Cool. I guess next on my list is Jordi. You had a question about GitLab?
Yes, so we are all all know that GitHub right now is the most popular repository of open source projects, but we are also seeing that some communities or some open source communities are moving to GitLab. So I was wondering how feasible it is to create a Probot version for GitLab. Could you be able to reuse most of the code that you have and just add to the GitLab API? It's a completely different environment. Have you looked into that?
I have not looked into that myself. Just from like other integrations that do build bots that work, on Bitbucket and GitHub and GitLab, I know that it's possible, but the API surfaces are very different. So it would be hard to make the exact same bots easily run on all three platforms, and it is out of scope for Probot. But it's an opportunity maybe to create a framework which would let you build maybe a more constrained bot, but at least it would work with all these popular Git hosting platforms, not only on GitHub.
Thank you.
Okay, thanks. Next up would be Marieli.
Okay. Hi, Gregor. Thank you for your talk. And my question is, how do you see the future of these bots on open source projects?
Well, hi, Marieli. Nice to see you. That's a good question. I think that at least GitHub is heavily invested into machine learning. And I think that right now they are using a lot of sophisticated bots for security. So like automatically analyzing like millions of lines of code and deriving from it what potential security problems are and surfacing these automatically without you needing to have this knowledge yourself, or helping you refactor in your code automatically. But that's something that is happening right now. But in the future, I hope that the bots on GitHub at least will become more interactive. Right now, it's kind of hard to interact with them as a user, and it's not very nice. And there's a lot of bad pushback against a lot of bots that do stuff automatically. That are less helpful and more annoying to some, and I hope that is something that we can do better. And I also hope that we will get a better understanding of what are situations where bots are good and what are situations where bots are rather harmful. And I know this is some research that you do yourself, and it's something that I watch closely. And I hope that we can learn from that and maybe create bots that don't act directly with users, but instead create bots that have like a back channel with maintainers to support them in the day-to-day work, but have maintainers be the last person to, for example, thank new contributors instead of leaving a bot do that.
Cool, thank you. Alexander has a question on code of conduct, I think.
Yes, I was wondering whether there are some kind of rules of behavior for Probot-based bots or for GitHub bots in general, things that the bots should do or things that the bots should never do.
I am not aware of it. we give some recommendations, I think, in the Probot documentation, but I am not aware that such guidance exists coming from GitHub. But this is a very good question.
What would be an example of such a mandatory or prohibited behavior from your personal perspective?
And from my personal perspective, in theory, you could build bots that impersonate my personal account. Like it could just authenticate with my personal access token, and it could appear as if I do something which I'm really not. So sometimes I've seen it several times. You see, like, you know, some startups create a new service, like a new CI service, and then they spam thousands of, you know, repositories telling them like, hey, why don't you use our new CI service? And although it's a human account, you can just tell that it's not, right? Like the messages are very repetitive, and I think this is what Mehdi's research team is also looking at. And this is something that is forbidden because it's spamming. Like that is definitely something that is forbidden. But beyond that, I mean, obviously you shouldn't harass anyone, just like you shouldn't do as a human. So I guess the same code of conduct applies, but I'm pretty sure there should be some more guidance for bots, not only, you know, to run into code of conduct problems, but also to be more effective as a bot.
Okay, cool. Very interesting discussion. I have one more that's similar to one I had from Marco.
Okay, and it seems that it's similar to the previous two questions as well. Are you aware of any cases where people put the bot and then rolled back? What are the main criticisms of using bots in projects that you hear about complaints that people get annoyed, maybe?
Yeah, I think the most famous example is the stale. It's a stale bot that closes issues after there was no interactivity for, like, by default, I think 30 days. So people create a new issue and maybe put a lot of effort into it, and then no human response. And then suddenly there is this bot saying like, oh, there is no activity, so I guess I'm gonna close this in 7 days unless there is activity. And I think that is something that we can improve. Like, I understand the frustration, but I also understand as a maintainer that I just cannot respond to every issue and nobody's entitled to my attention. But I think for this particular case, people are complaining that issues are just closed without them being resolved. So I think the stale bot could be improved to only consider an issue stale when one of the maintainers responded. And then when the author doesn't get back to the maintainer, then that is probably more valid to close the issue, but it shouldn't be closed if nobody at all gets back to an issue. And there are some more problems with bots creating a lot of noise. You know, like I worked on a bot which automatically updated dependencies called Greenkeeper. And especially in the early days when there was like a new release from a widely used library like Lodash or something, we would send thousands of requests at once, and it would just create a lot of maintenance overhead. And people complained that, you know, this is causing more problems for me than it helps. So noise is something in general that I've seen people complain about when it comes to bots, because it's easy for bots to create noise, but handling noise for humans is hard.
Yeah, my question was a bit similar, I think, in the sense, do you have a feeling if there's a general positive vibe, acceptance of bots and developers, or is it more negative and hostile, or is it difficult to say for bots overall because it depends on the individual bots?
Yeah, it not only depends on the bots, it also depends on the context. I think it's fair to say that our work would be impossible today without bots. And I think that the acceptance is high for bots that are very objective. Like when a bot tells me the test is failing, I don't need a human to tell me that. I appreciate the bot doing this. Or like I'm using bad syntax and a linter bot tells me like, hey, we usually like to put semicolons at the end, and maybe even offers me to fix it for me. Like, this is great. Like, it's kind of negative feedback in a way. I don't need a human for that. But when it comes to you know, to praise, for example. Like I don't need a bot to tell me, well, great job, you know, automatically after my issue is closed. Like I think that is rather dull, and I think that is something that a lot of people do, and I don't think it works. But that being said, it has not really been researched as far as I know. So that's like more like a subjective observation from me.
Thank you. And there's a question from Suhaib.
Yes. So my question is, there is some problems. We see it like they approach it to be solved by bots, but do you think that some issues and some problem could be better solved by traditional tools like command line tools or a web tool that, for example, when there's some issues that doesn't have any interaction, having list of them, you can close them by at once or something like that, instead of just having bot to meet that?
Yeah, I think it really depends on what you want to do. I think like having a web app with a nice UI where you can put in a lot of contextual documentation might oftentimes, for a user perspective, be the preferred choice, but it's much more work. So I think honestly, this is the reason why we don't have so many of them. It's much easier to create a CLI, for example, where there is no UI you need to create. I can't recall a place where I would think, why is this an app? Why isn't it a CLI for myself? But I could imagine that exists, yeah.
Okay, we have one final question from Neil.
You want me to ask it? Yeah,
sure.
My question is, you know, with respect to the bot that closes issues, and you know, you said, or not closes issues, but praises you for closing an issue or having one close. What's the best way to get feedback on this being a useless bot? I mean, other than you looking at it and going, this is useless, how can you get feedback? You know, is it via some automated mechanism where you can click on, you know, +1 or thumbs down?
Yeah, I mean, you can kind of observe how people react to it, and there is like an emoji reaction to comments, also to bot comments, with a thumbs up, thumbs down, a heart, and other things. So you could, in theory, measure like how many thumbs down does it get. But a more sophisticated measure, I guess, would be to measure retention, you know, of contributors. And over time, I guess you need a bigger project for that, and you need like a proper research setup. But you could see in one repository, one project, I have that bot enabled, another I don't, and then see if it has any effect on people coming back or not. Like I would be very interested in studies like that, and I'm not aware that any have been run where you could compare what happens if there is no comment at all, what happens if there is a comment by a bot, what happens if there is a comment by a maintainer. I only have my own assumptions and my own observations, but there is like not a real study that I'm aware of that could tell, you know, this increases retention by something like 10% or something. That would be great to know.
Like an A/B test or something.
Yeah.
Thanks.
All right, I think we reached our time limit for our Q&A, but maybe we can come back to some of the things in the open discussion. But Gregor, thanks again. Really great talk, and great for you to take the time to be here with us today.
Thank you for having me.
I'm virtually clapping and physically. Thanks again. So that is probably the time that we bring up the next talk video, which is an exploratory study of bot commits. We will look at the video and then have, I think, at least 2 of the authors here to discuss.
Hello everyone. In this presentation, we are presenting an exploratory study of bot commits, over 12 million of them actually, that we hope can give us a deeper understanding about them. I am Thapajit De, a PhD student at the University of Tennessee, and I worked with Bogdan Vasilescu from CMU, and the project was overseen by my advisor, Dr. Audris Moscas. Now, I don't believe that I need to give an extra motivation for studying bots to this community. However, I would like to highlight a few interesting things. For example, in this instance, a bot found a vulnerability in a dependency of a project. A bot created a pull request for fixing it. The pull request was verified by a CI bot. The pull request was even merged by a bot, and the bot celebrated the merge with a GIF. So that's how sophisticated bots are becoming nowadays. In fact, it is not uncommon to see the bots as being one of the top contributors of a project. In this case, a bot named Scala Stewart made more commits to this particular repository than the creator of the repository himself. Although the total number of lines changed is much smaller, but this reveals the impact of bots in the current state of software engineering practices. Now, the overarching goal of this project is to get a deeper understanding of the bot commits. We are trying to characterize the commits by the type of file operations performed by the commit. That is, whether a file was added, deleted, or modified. We are also trying to see what type of files and languages these bots work with and identify the file types that are modified together with other types of files. The data for this study was obtained from our paper, Detecting and Characterizing Bots That Commit Code, which was published in this year's MSR conference. A quick summary of what we do in that paper. We present a systematic method for detecting code commit bots called BIMAN, which stands for Bot Identification by Commit Message, Commit Association, and Committer Name. Now, our method is a combination of 3 heuristics, the result of which is combined in an ensemble model to answer the final question: is the commit author we are looking at a bot? For more details, please have a look at the paper. Now, while working on that project, we compiled a dataset of over 13.7 million commits created by 461 bots, each with over 1,000 commits, and made this dataset available through Zenodo. This data contained information on the files modified by the commits, which is what we are looking for in this project. After doing some filtering on the dataset for removing the ones without a changed file or for which the files could not be located, we are left with over 12.3 million commits. And that is the dataset we used for this study. However, that dataset also has information about the author ID, the commit SHA, the time of the commit, time zone, and the commit message and the projects this commit is associated with. So if you think this might be useful in your study, we invite you to take a look at the dataset. Now, from that dataset alone, we can address 2 of the questions we asked. What are the file types and languages these bot commits modify, and which type of files get modified together? However, to know if a file was added, deleted, or modified by a commit, we need some extra information. For getting that information we required, we looked at the World of Code dataset, which contains version control data from all open source projects that use Git. The dataset we used contained over 116 million unique Git repositories and over 1.8 billion commits. This dataset was introduced in the MSR 2019 paper about the same topic. So to identify if a file was added, deleted, or modified by a commit, we search for the blobs associated with it before and after the commit. Blobs are how the contents of a file are typically stored in Git. Using the APIs provided by the World of Code, we created a C2FBB map, which stands for commit to file to the old blob associated with the file before the commit and the new blob associated with the file after the commit. This makes answering this question very simple. If we don't see a new blob, that means a file was deleted. If we don't see an old blob, that means the file was added. And if we see both new and old blobs, that means the file was modified. Now, let's try to characterize the bot commits by the file operations. First of all, we can have commits that do only one type of file operation for all the files it updates. It either adds, deletes, or modifies these files. Then there are commits that do 2 different types of file operations. For example, it might add some files and modify some other files. And finally, there are some commits that do all three types of file operation in a single commit as well. Looking at the file operations performed by bot commits, we see that an overwhelming majority of them just modify these files. Additions are the second most common, though they are around 10 times rarer than modifications. Deletions were found to be very uncommon. We also found that the bot commits rarely perform more than one type of file operation. And even for such commits, the ones involving file deletions were particularly rare. In terms of the number of files changed, we found that most of the bot commits only update 1 or 2 files. However, the maximum number of files modified by one single commit was found to be a whopping 1.1 million. Looking at all the instances of all file updates, we see that almost half of those instances are file modifications. 68% of the commits we studied modified only one file, and around 5% of the commits modify more than 10 files. Now let's look at the file types these bots work with. To identify the file types, we look at the file extensions, extract those file extensions, and for identifying the file type, we use the linguist tool provided by GitHub. The files that are not covered by the linguist tool, for example, files like .aurinfo or .icloud, are marked as others. So we found that the files of type, configuration, documentation, data, and the files related to web development languages like HTML were the most frequently updated ones by the bot commits. We have much more details about that in the paper, so if you are interested, please go and take a look. Now let's look at which type of files are modified together. We used association rule mining for identifying the file types that are modified together. We found 323 non-redundant rules with the minimum, median, and maximum sizes of 2, 4, and 6. The support for those rules were relatively lower, but they had very high confidence values. The lift was positive in all cases, suggesting that the rule does find the file types that get modified together. Now let's look at the top 5 association rules we found by the lift values. We see that the files of type ignore list are most frequently modified together with other type of files. We can also see that the confidence values associated with these rules are pretty high. This graph visualizes all the association rules we found. The nodes in the graph are the different file types. The lines in the graph connect all the file types that are present in a particular rule. So the type of files that are frequently modified with other types of files have a higher connectivity. So this graph shows us that the file types that do get modified frequently with other types of files also include Markdown, YAML, JSON, text, shell, and we can also see a nice cluster showing HTML, JavaScript, and CSS files are frequently updated together. Finally, we share the C2FBB map that we created through Zenodo, which includes information about over 150 million instances of file updates by all the commits that we studied. So this file contains information about the commit SHA, the file updated, the blobs associated with the file before the commit and after the commit. So this concludes our presentation. In summary, we found that the majority of bot commits just modify files. Files of type, configuration, development, data, and types related to web development are the ones that get modified more frequently, and the files of type ignore list, markdown, YAML, JSON, text, shell are the types of files that get modified frequently with other types of files. If you have any questions, please do reach out and drop me a mail. Thank you.
Stephanie, you're muted.
We can't hear you.
I try. Okay. Now? Okay. Sorry. Oh, so thanks again for the great talk. I think we have Tapashit here and Audris as well, I think. Audris, feel free to also chime in if you want. already have a couple of questions in the chat. First one was, I think, from college. Do you want to ask the question?
Yes. First of all, thank you. Thank you so much for this great presentation. This is like a huge asset, to be honest. This is really good. So one question I had is, from the bots that you've analyzed, you said there's almost 500 bots. Did you see that most of them, or a large number of them at least, are project-specific bots? That is, a bot that is designed for a specific project, say TensorFlow or something, right? Because those usually are more optimized, and developers would trust them more to commit code, for example. So I just wanted your insight on that.
Right. So from the for the 461 bots that we saw, most of them are not actually specific to a project. So they are like cross-project bots. Like, for example, we have the so we have the Greenkeeper bot, then the these CI bots, then we have the Dependabot is also there, that takes care of the updating the dependencies of a project. So these types of bots are more common because we only selected the bots that have more than 1,000 commits. So for a project specific bots is not very common to see more than that many number of commits for one particular project. So I think most of the bots that we have in the dataset are not specific to a project.
Thank you so much.
Sure.
Next question is from Neil, which is similar. Is this answered, or do you want to add something?
I guess I'm just curious whether there's this is the paper is looking at it across all of the bots that you've collected, and I'm wondering if there's wide variation per repository as far as what work the bots are doing. I'm guessing there is, but whether you have any insights into, is there a repo where bots do most of the work, for example?
So we actually have not specifically looked at that, but my understanding is that they do mostly very small type of work, because as you saw that the files changed by these bots is quite small. They generally update a few dependencies or something like that. So I did not actually study that directly, but I think most of the work they do is quite small.
Thanks. I guess as this is such a fast-moving field, the data set would change dramatically from when you collected it to next year, for example.
Right. Yeah. So are you asking if we will have an updated version of that?
I'm asking. I think that'd be great. I'm not sure if you want to do that or not, but
we can do that. I mean, it's not too difficult to do. Maybe once a year or something.
So just a suggestion. So the Tapajiti pointed out to World of Code, and there's this has this map that you can use to map these commits.
Audris, can you make yourself a bit louder?
Can you hear me? No.
Not very good.
No. Yes. No.
No.
No. Okay. Let me work on my sound, and then I'll think about that. I'll work on my sound first.
Okay. Maybe Philip can ask his question in the meantime, because I think it fits nicely.
Yeah, I was just wondering if you also looked into what types of bots you actually found. Like, can you give us an insight of are there specific types of bots that you see a lot, or are they all doing very different things?
So based on the thing that we saw, like when you say the what type of bots are there, it's kind of a subjective question based on how you say, like how you define the types of the bots. But if you say what type of work they do based on what we studied, so there is some data on that in the other paper that we got this data set from. What we saw is that many of these bots, they work at very regular hours, but there are a few bots that work kind of in sync with human developers also. So that kind of tells us that there are some bots that do a regular update of something, and there are some bots that maybe a human developer like makes a commit, and this bot checks that, and if that thing like assess some tests, then it kind of checks in those commits. So there are some type of bots like that, but there have been some kind of taxonomy of these bots that were suggested in some higher studies. We did not have like a formal taxonomy of these bots like that.
Okay, I think looking at the time, I would only pick up one question that has been asked twice in the chat from Tom and from Mehdi. How much effort did it take to create the data set? Because it seems quite a lot of reviewing. How much effort did it take?
Right, so the data set was actually created from the World of Code data set that we used. So creating that data set is a huge effort, but once you have that, after that, creating the data set that I used is not that big a deal. So maybe Dr. Moscas might want to say something on that.
Yeah, so I think the difficulty, is my sound a little bit better now?
Yes.
Yeah.
Thank you.
Sorry about that. So yeah, so the process goes as follows. First, you go through the list of authors. There, I think in version Q, there are about 38 million. And then you decide, design some algorithm to decide whether this is a bot or not a bot. And then once you have a list of bots, then you essentially map that author name. So World of Code contains that, so you can immediately produce the list of all the commits produced by these bots. And from the commits, you can get projects, files changed, et cetera, et cetera, et cetera. So it's, well, technically speaking, it's like 3 lines of code. You just need to know what you're doing, and you need to wait a little bit until it's done.
Okay, cool. Thank you. I think we need to stop here. Maybe we can pick up some more questions in the open discussion later on, but I would like to go to the final talk of the second session, which will be about detecting whether a bot committed something or not. So bot or not, detecting bots in GitHub pull request activity based on commit similarity.
Hello, I'm Mehdi Gorzadeh. I'm PhD student in Software Engineering Lab at University of Mons. In this study, we have proposed a new approach for detecting bots in GitHub pull request activities based on command similarity. This research is presented to the second international workshop on bots in software engineering. To begin, we need to get familiar with the concept of online coding platform. Today, software developers, especially open source developers, are increasingly using these platforms to commit their changes to code base, use new methods of code contribution like pull request, and also doing code reviews. As these platforms are getting more and more popular and they host millions of projects, maintainers tend to rely on bots to carry out routine tasks and to interact with project members to facilitate their works. Studies have shown that bots improve collaborative development in several different ways. For example, improving software quality by automated refactoring, generating patches for bugs, continuous integration, automatically closing abandoned issues and pull requests. What's a pull request? It's a method of code contribution which allows developers to participate in different projects without having direct commit access. To submit a pull request, one can create a fork or clone a repository, make changes, and submit a pull request easily by putting a title, a description, and clicking on the Create Pull Request button. After submitting a pull request, it will appear in the list of pull requests, and maintainers will decide whether to merge it or not according to the quality of changes. If you have a look at the list of pull requests, we can see that there are a lot of comments and discussions in these pull requests, and if we open one of these, we can see that bots are involved in these discussions. We believe this can bias a study's targeted pull-based development and more generally social codings. For example, the presence of bots makes it difficult for empirical studies to distinguish human behavior from automated behavior, and other studies like identity merging or social aspects like contributor onboarding, contributor abandonment, team productivity, and team collaborations can be influenced by the presence of bots. More specifically, in our last study about acceptance or rejection of pull requests, we noticed that proportion of accepted pull requests with presence of bots is almost twice pull requests without bot comments. This means they need to be considered by researchers. This subject is directly related to our goal in SQAssist project to study software ecosystem health. So we decided to find a solution for this problem. The current method to identify bots on GitHub is based on a combination of different methods. It's a manual and effort-prone process and not easily reproducible, like looking for previous studies about well-known bots and the presence of a string bot in user identity. So having a ground truth was an important task in our study. We created a dataset of accounts that are currently active in 1,200 projects of cargo ecosystem. We manually identified 42 bots and 250 human accounts, and all of these accounts manually and independently checked and verified by two distinct authors of this paper. The underlying idea of our study, which is to propose an automated approach for detecting bots in GitHub, is based on the hypothesis that bots exhibit more repetitive messages than humans, since they are expected to automate repetitive tasks, while the variation in comments made by humans is expected to be higher. This figure shows comments of a sample bot in our dataset, and as it's clear, comments are very similar. So we decided to measure this similarity of comments by two well-known distance metrics. The first one, Levenshtein edit distance, which works more on the structure of the text by counting the number of single character edits like deletion, insertion, or character replacement. And the second one, Jacquard distance, which works more on the similarity of the content and compares the number of distinct common words in two strings with the total number of distinct words in them. We computed the Levenshtein and Jacquard distance of all pairs of PR messages of each identity. The figure shows mean Levenshtein and Jacquard distance of all comments of each identity. Clearly, humans have higher Jacquard and Levenshtein distance than bots. Also, we can see that both distances have very similar results, but the presence of dots outside the diagonal indicates that both distance metrics are not redundant. In this figure, we can find bots and human accounts with the same Jacquard distance but different Levenshtein distance, and conversely, we can find human and bot accounts with the same Levenshtein distance and different Jacquard distance. Even if humans can be identified on the basis of higher mean distance, this does not effectively distinguish them from bots, since we observed that some bots also have such high mean distances. We manually inspected those bots and we noticed that while they do have repetitive messages, these messages follow several distinct patterns, implying a higher distance value when messages belong to different message patterns. We assume this similarity comparison works, but it's not enough to catch all bots. Therefore, we came up with the idea of counting the number of patterns. In this figure, we can see comments of a DevOps bot with 3 different message patterns. So we decided to compute the similarity of sets of comments instead of all comments, as we knew messages follow several distinct patterns. We guess that human comments spread across many small clusters and bots will have very small number of large clusters. Therefore, we applied an intermediate clustering to identify the number of patterns of comments for each identity. We used dbScan, one of the popular machine learning techniques for clustering tasks. We selected this technique because it has the advantage of not requiring to specify the number of expected clusters. It can generate clusters of unequal size, and also it allows clusters to contain a single item. We used combined Levenshtein and Jacquard distance as our distance metric. The figure shows the number of resulting clusters and the number of considered messages for each identity. As we can see clearly, bots have a lower number of clusters regardless of the number of messages, and all 42 bots have 10 clusters or less. We can also observe that 249 out of 250 humans have at least 14 clusters. Our approach can classify bots based on the threshold of 10 clusters with the recall of 100 and the accuracy of 97.7%. The limitation of our work mainly lies on the size of our dataset. We have a dataset of only 292 GitHub identities, all from cargo ecosystem. Another limitation of our work is that the cluster of comments is the only decision factor, while, as we saw, the number of comments could be considered as another factor. We decided to continue this study, so we already manually verified 5,000 accounts from 169,000 repositories from 37 ecosystems. We want to create a classification model instead of a threshold for clusters, and also we want to include more features like number of comments, empty comments, and Gini value as distinguishing metrics. And also we want to provide a tool. To sum up, we explained about pull-based development and presence of bots in social coding platforms and how this presence can affect studies related to software ecosystem health. We explained our approach and the result. Our approach is based on the comment similarity and clusters of comments. We computed clusters of comments with the combination of Jacquard and Levenshtein distances. We showed that our approach classifies accounts with high precision and recall. We also further worked on this subject and we created a bigger data set, and we considered more features to make a better model to classify, and also we decided to create a tool to make it more useful for the community. Thanks for listening, and any question?
Thank you so much for this talk. There's already a lively discussion in the chat. I think Tom is already answering all the questions. But I think we should nevertheless start with the question Alexander brought up. Do you want to ask that question?
Well, yeah. So without being disrespectful, but those two talks, so the previous one and the current one, appear to be quite similar. So what I'm trying to figure out is what are the differences? Are they looking at different kind of data, or are they looking at the same of data but using different heuristics?
Actually, my data set was on PR comments, and the previous study was on commit comments and combination of the other heuristic like bot name in the bot string in the username. And if you can explain the other. And
essentially, you are looking at the metadata, and Tapajit is looking at the data itself more. Like this would be the difference.
They use a combination of these two.
So,
but we use just PR comments in this study, and we are extending to issue and PR comments in our extension study.
Right. So I think the study we had, we studied the bots that make some code commits, and that I think made the study. It looked at the pull request, so it's not exactly the same bots because the bots that create commits, they don't always make pull request and vice versa. So it might not actually be the same bots. But I can share the performance matrix that we had. So if that would be useful. So just to take a look at that. So this is the performance matrix we had. So this beam is basically the bot identification by commit messages that we had. So we had the following AUC and the precision and recall. So that's what we had. And the final model we had an 0.9 AUC. So that's the thing that we had.
Thank you very much.
Thanks. So I see another question from Eleni on how you made sure that commit message or pull request is really from a bot or not. Eleni, do you want to ask the question? Probably I didn't get it.
Yeah. Right. Can you hear me?
Yep. Okay.
So because based on my own experience, when you investigate accounts to see if they're bots or not, it's not always clear. Let me also turn on my video. So here my question is, how can you be sure that indeed what you found to be a bot, that indeed it is a bot? Or if you have, let's say, gray area cases that you disagreed, and if you did, some more information on those cases would be very interesting to know. Because as Alexander also mentioned in the chat afterwards, it could be bots impersonating humans. So the choice might not always be clear. If you can elaborate on that.
Actually, in our extension study, we found bots that actually we call them mixed accounts that a person uses a bot or automated tool to do repetitive tasks. But we excluded them because even by human eye, you cannot detect them if they are human or bot. And we just kept bots and human accounts. Those we are sure that are bot, and those we are sure that are human.
If I may follow up. Basically, this gives me the impression of selection bias, because if it's clear to you, it becomes more clear to the classifier as well. So it would be really interesting to investigate how to sort out these cases, because these are indeed the most tricky ones.
But these cases are less than 1% of accounts. We found such cases, but these are not too much.
And their activity was not much too?
Their activity depends on their projects, or, for example, these kind of activities are mostly by users that have several different projects, and one of the projects is managed by bot or one of the project or bots are involved in some specific task, and they do different other tasks. But the number of these type of accounts is not too much.
Thank you.
Good. I have another question by Francisco on the bigger data set.
Yeah, I think it's mostly a small curiosity on the plans moving forward, because distance measures, they are known because they're incredibly slow due to like the amount of pairwise comparisons that they have to make. Especially I think after when you get into the thousands, it takes a long time to run everything, especially for Levenstein. So I was wondering, like, have you experienced anything like that? And if so or not, like, do you have any plans on mitigating this risk moving forward?
Actually, we did have such a problem, but we tried to use at least 20 comments and at most 100 comments of each user. So we kind of mitigated this problem with limiting the number of comments. And in our new study and my tool, it has shown that the performance is very good for actually I tested for a repository with more than 100 contributors, and it was very fast to answer each account type.
Let me see. I think just as perhaps as a reference, like, because there's a lot of work, especially in testing, on how to use these similarity measures, and there's a paper that was published like with a fast approach, which is kind of like trying to speed up, at least for testing. But I guess in your case, instead of test cases, you would have pull requests, and then I thinking their approach could help you like speed up your and overcome this bottleneck with performance when it comes to the distance measures. Okay, so I can later try and contact you and send you this reference.
Thank you.
Good. I think that completes the questions on this particular talk. We'll have now a bit time for open questions. So do think about or post your questions in the chat. In the meantime, we'll set up a poll because, as you probably realized, we're quite behind time. And we will ask you to answer the poll on whether we should have the 10-minute break and go further over time, or if you should rather save the 10 minutes and start with session 3 right away. And I hope we'll have the poll running in a minute. In the meantime, anything you want to discuss over this whole session? Maybe I can start it off. I mean, it was an interesting combination having these two talks that can detect bots after the one where we learned how to create one. Gregor, do you think this is interesting and could be used at GitHub? That you maybe find instances of people or of bots impersonating people? Is it something you would use?
Yes, I think so. I mean, like my little example bot at the end, I needed to distinguish between humans and bots, and I, had this really naive approach. But that is something that I've been doing quite a lot in other contexts. I also think that GitHub could do a better job in showing not only the user account that created, for example, a comment, but also surfaced information whether the comment was created on github.com or using an API. I think that could make it more visible that, for example, for this mixed accounts that Mehdi spoke about, my personal user account, when I just comment, people see my normal avatar. But when I use my personal access token to do some automation, people would see that it's me, but that I created it using the GitHub API. Yeah, I will bring that to the attention of GitHub. It might be something they could do.
Cool, thanks. The poll is now ready, by the way. So on the icons and on the bottom, you have now the poll button. So please go ahead. Tell us if you need a break or not. And in the meantime, there's in the chat, Philip added thoughts. Do you want to articulate that?
Yeah, so it's not really a question so much, it's more an observation that I had also during the MSR talk that had a similar topic. So I think the current work is really interesting and very useful already, but it feels to me be a little bit of kind of the level 0 when it comes to detecting bots, because at the moment, a lot of these techniques seem to assume that the bots really don't mind being detected as bots. While when we look at social media, a lot of bot detection work there, it's not about detecting bots that, you know, that don't care whether you know that they are bots. It's about detecting bots that try hard to appear as users, as human users. And I wonder whether this will also be something that we have to deal with at some point, that it becomes a lot harder to detect bot commits because the bots try to look as much as possible like a human commit. I'm not sure exactly what the use case for that would be on GitHub, but so far people have always found a use case for this kind of thing. So, and I think the approaches we currently have are probably not going to work for that. So looking at the bot name isn't going to work then anymore, and probably looking at the very simple kind of patterns is also not going to work anymore.
All right. I think we have a pretty clear majority for not taking the break. And to make sure that we don't run too much over time, I would say we cut the open discussion a little bit short. We have still some open discussion time at the end. And this just gives me the opportunity to say thanks to all the presenters in session 2, and I will hand over to Marco here.
Okay, awesome. Thank you all. So let's start our third and last session. Now we have 3 papers. So I would ask the first paper of the session. So let's see the talk.
Hello, my name is Chris Brown. I'm a PhD student at North Carolina State University working with Dr. Chris Parnan. And I'm here to present our work entitled Sorry to Bother You Again, Developer Recommendation Choice Architectures for Designing Effective Bots. The motivation behind this work is the idea that decision-making has become a vital part of software engineering. Amanda Wu, who writes for the Hacker Noon technology blog, suggests that the most important skill in software development is not how good your coding skills are or how much you know about machine learning and data science, it's decision-making. So this goes to show that the ability to make good and effective decisions is a crucial part of being a software engineer. Unfortunately, developers often make bad decisions. One example of this is found in prior work by Raman and colleagues, who show that software engineers often hard code passwords and secrets into their configuration scripts. This is obviously a bad decision because other people can access these files, and this also presents security vulnerabilities for your software and applications. So the goal of this work is to address this tweet by Greg Wilson, a software engineering researcher, who suggests the most interesting topic for the next 10 years is how do we get working programmers to actually adopt better practices. Specifically, I'm interested in finding ways to help developers make better decisions and adopt better behaviors in their work. So this is the BotSE workshop. Why not use bots? As software engineering becomes more globally distributed and software developers work remotely and apart from each other, it's becoming increasingly important to find automated ways to help developers make better choices. So prior work looking at bots shows that bots are effective for automated continuous integration tasks, running tests, helping out with code reviews, integrating tools. Overall, developers find bots extremely useful for automating development tasks. However, developers often face challenges when interacting with bots. So Wessel and colleagues show that even though bots are effective for helping developers complete development tasks, developers often face challenges interacting with bots because they have poor decision support mechanisms, and they can also provide incomprehensible feedback. So the goal of this work is to improve the bot-developer relationship to help bots make better recommendations to software engineers. So last year in BotSE 2019, motivated from the movie Sorry to Bother You, we introduced this naive telemarketer design. This is a baseline approach to describe how bots make recommendations to developers. Similar to a telemarketer, this approach makes generic recommendations without any context or any customized messages to users, but a blanket recommendation for a specific software engineering behavior or practice. We implemented this design in Tool Recommender Bot, which automatically recommends static analysis tools to developers using automated pull requests. For our evaluation, we looked at ErrorProne, which is a static analysis tool for Java, and we analyzed this tool on 52 GitHub repositories. Here's a sample pull request from Tool Recommender Bot using our naive telemarketer design. As you can see here, it's a very generic recommendation without any customization for the repo. It just presents a sample error and a sample error message presented by ErrorProne. And we suggest they can use this tool in order to find and fix more bugs in their code. So, as you can imagine, this was a very ineffective way to make recommendations to developers. Only 2 of our 52 pull requests were accepted. Developers also provided a lot of feedback in the pull request comments on why they found this recommendation ineffective or why they closed or ignored it. We summed this up into 2 main categories: social context, which refers to the social aspects of software development, working as a team and contributing to a project, and then also developer workflow. So the workflow of developers, we also found that our pull requests failed existing checks for most projects of systems that already have built in continuous integration, and we also provided more work by introducing more errors in the code. So what can we do to improve? How can we improve the effectiveness of bots to avoid making problems with social context and developer workflow to help developers ultimately make better decisions? So we propose using nudge theory, which is a behavioral science framework to improve the decision-making of humans. A nudge refers to any factor in decision-making that does not offer an incentive or ban alternatives. So you cannot pay people to make better decisions, and you cannot ban people from choosing bad behaviors. The driving force behind nudge theory is this idea of choice architecture, which suggests the way that choices are framed and presented to users actually impacts the decision they make. One example of this is in the design of a grocery store, as we see in this Simpsons cartoon here. The way a grocery store is set up actually impacts the decisions that people make in a grocery store. For example, research shows putting fruits and vegetables at the front of a grocery store encourages humans to consume more fruits and vegetables in their diet. So Johnson and colleagues introduced 11 practical tools for choice architecture to integrate into any recommendation or any target behavior that you want humans to improve. We analyze these 11 and present 3 developer recommendation choice architectures: actionability, feedback, and locality. These are specific ways to frame and present recommendations to developers in order to help them improve their behavior based on the tools on the left. For the paper and for the rest of this presentation, we will focus on actionability. So actionability refers to the ease with which users can act on recommendations. Going back to our grocery store example, if you put donuts at the front of your grocery store, this makes it easier for users, or in this case, grocery store shoppers, to grab donuts and eat unhealthy foods. But again, research shows that putting fruits and vegetables at the front of the grocery store increases the amount of fruits and vegetables purchased and the healthier foods that are consumed by users. So we present our preliminary evaluation. In this study, we looked at 15 professional software engineers and we gave them a survey. The survey featured 2 automated recommendations, one that we refer to as a static recommendation and one as an actionable recommendation, which we will see on the next slide. The idea behind the recommendations is fixing PEP 3105 errors, which makes print a function. Python officially switched over from Python 2 to Python 3. In Python 3, print statements are no longer statements, but they are functions, so strings need to be contained in parentheses. Python also says this change will render most of today's print statements invalid. So we want to encourage developers to not only make this change, but to also update to Python 3 by using PEP 3105 recommendations. So in our static recommendation, we simply present a comment on a pull request. Here, the comment says that the latest Python version uses print as a function instead of a statement. Here's a fix for this line of code in question. So PEP is a style code that's generally accepted by most static analysis tools to analyze Python code. Here we present a fix for this error with the print passed in parentheses. And we also suggest upgrading to Python 3 overall. In our actionable recommendation, the content of the recommendation is exactly the same, except this time we're using the GitHub suggested changes feature. This feature allows code reviewers to provide feedback to contributors on their pull requests by making specific code suggestions. It also allows the contributors to automatically apply the suggestions from the reviewers to their code using this commit suggestions button. You can automatically commit it to your pull request without having to go and commit a whole new version of the pull request on the project. All right, so in our survey, we presented developers with both the static and actionable recommendations. We found that 100% of the developers, all of them, preferred the actionable recommendation. In our survey, we also gathered qualitative feedback for why they felt that the actionable recommendation was better than the static one. So going back to our tools for choice architecture, the tools that we use for actionability refer to technology aids and using defaults. So the default rule says that if you have a list of options, most people will automatically select whatever the default is. For technology aids, we found that developers found that the visual aspects of this tool, the GitHub suggested changes feature and our actionable recommendation, made it easier to read, provided better feedback. A lot of people were familiar with the Git diff format, and this was ultimately better for them to make an informed decision on whether or not to accept this recommendation. So here P15 talks about the visual spacing and colors, makes it easier to read, less easy to ignore, and it gives the option to quickly fix. For defaults, participant 14 says that both recommendations provide the same information, but recommendation A, in this case, which is the actionable recommendation, also handles some of the work needed to act upon it. So it's more helpful for the recipient. It allows you to automatically apply the recommendation to your code. So the implications of this is that we believe incorporating these developer recommendation choice architectures, actionability, feedback, and locality can improve the effectiveness of bots and help developers make better decisions. In future work, we aim to do a further study on actionability and also evaluate the rest of our recommendation choice architectures to see what impact they have on helping developers make better decisions and ultimately improving the behavior and decision-making of software engineers in their work. All right, thanks for checking out my talk, and sorry for bothering you.
Okay, thank you for the talk, and let's open for questions. And I really liked the idea that you used the behavioral science theory to support your research. So maybe I will start with this first question. What is this theory used for in other areas, and why did you choose it?
Right. So generally, behavior or nudge theory is focused on general human behavior. It's actually used in a wide variety of other fields. So behavioral science is used a lot for marketing and economics. So how do you advertise things that people want? It's popular in psychology, a lot of more of the human interaction fields, I guess. They use it quite frequently. Also for like, the governments have used it before in terms of helping citizens maintain better behavior, encouraging them to adopt better behaviors and prevent crime and stuff like that. So there are a wide variety of uses, not quite so many in the technology fields yet.
Okay, yeah, good job in bringing that for our attention. And we have a question from Oscar. Maybe you can ask aloud.
Yeah, thank you for the great presentation. Yeah, I was wondering about the complexity of the decisions developers have to make and how this theory that you used helps with that. I mean, do you think recommendations for certain sort of difficult decisions can well, help developers like solve or make these decisions?
Mm-hmm. Right. So I think in this case, the difficulty of the decision would play a role in which what the developers or whoever decides. For example, like saying they should fix this error, this PEP 105 error is a lot easier to adopt than say, here's a new tool for your project. You should use this to analyze your code or build your system or whatever. So that's something else we try to look into. I think in general, with the architectures, specifically looking at actionability, if you make it easier for people to adopt the behavior, then what we hope to see is that no matter what the behavior is, the easier you make it, the more likely the developers would be to adopt it.
Thank
but
you.
That's still stuff to look at too.
Okay, and do you have any plans to implement that on an actual bot?
Yep. So currently we're looking at a bot. Goes back to how do we actually test this? We're looking at a bot for students. So we're developing a bot to encourage students to adopt better software engineering behaviors. So similar to making good decisions, except for instead of professional developers, we're looking at how do we help students adopt better behaviors, not procrastinating, testing early, different things like that.
Okay.
That's still in progress.
We have another question. Tapajit, can you ask it aloud?
Hi, so thank you for the presentation. It was really great. So I understand that that an actionable recommendation is much less is much less easy to ignore, but say in some case the developer is not trying to have the recommendation, I mean, they are not trying to accept it. So how will that change in that particular situation?
Right. So that's a good question. For nudge theory, one of the kind of main things of nudge theory is that you can't force people to adopt better behaviors. So like you can't prevent them from bad behaviors or not adopting the good behaviors. So in this case, the actionability would make it easier for people who may be open to adopting it. So a lot of times the barrier for adoption is it's too hard to integrate into my code or it's too much to learn. So if we lower the barriers to adoption, that would help developers who may be open to adopting the tool, but at the same time, we don't want to force people to adopt it. And so in that case, they'd still have the option to ignore the recommendation.
Okay, we have one last question, Alexander.
Thank you very much, Marco. So the ease of choice in the nudge theory assumes that you are making a decision on your own in isolation. But it is also known that decision making by humans is influenced by social aspects. So for instance, I might be following somebody, an existing trend, or I might be opposing an existing trend. So do you think this plays a role in your setting? And if yes, how?
Right, I think so. One of the things in a prior study that we found was when looking at recommendations, one of the things developers want that makes an effective recommendation is information about the popularity of this was a tool recommendation, so popularity of the tool. So they want to know, like, what do people in the field say about it? How many downloads or uses does it have? So that's a very important thing that developers find for making an informed decision on whether or not to adopt the tool. Also, where they find out about it. So if it's on a trusted source, rather than like some random email or from some random bot type of thing. So we found that plays a role as well.
Thank you.
Okay, thank you for the speaker. So let's go to our second presentation from Marielle.
Hi everyone, my name is Marielle Vessel and currently I'm a PhD student at the University of São Paulo in Brazil. I'm going to present the paper, The Inconvenient Side of Software Bots on Pull Requests. This research was done in collaboration with my co-advisor, Igor Steinmacher. Social coding platforms such as GitHub are widely used to host open source software projects. Over the last few years, software bots have become relevant for these platforms. These bots are basically an interface between human developers and services. And in order to save developers' time, bots automate routine tasks and interact with human developers. On GitHub, bots work on many different tasks. Bots are usually created as a GitHub user that can submit code contributions, interact through comments, merge or close pull requests. Bots have spread across all pull request workflow. As we can see here in this figure, some bots automatically check the pull request source code, searching for broken dependencies, vulnerabilities, or bugs, and then submits a pull request for fixing these issues. There are also bots that help during the code review phase, aimed to facilitate discussions and feedback. There are bots, for example, that comment on pull requests that do not satisfy specific rules defined by project maintainers. In addition, there are also bots that can congratulate newcomers or report some tests and code covered reports. Other bots help closing and merging pull requests. Previous work have focused on designing bots to be integrated into the pull request workflow to perform a lot of tasks such as code refactoring, bug repair, tool recommendation, duplicate development detection, dependency update, and mention review. One of the contributions of this paper is defining what is a GitHub bot. Our definition of GitHub bot reflects on how a bot works on GitHub. So, in summary, a GitHub bot is a specific category of software bot. It's a task-oriented bot responsible for automating well-defined tasks on GitHub repositories. A GitHub bot behaves like a human user, serving as an interface between users and services. GitHub bots have become your voice in the pull request conversation. Even these bots are useful for saving maintainers' time. The way these bots interact on pull requests, leaving a dozen of comments, can be disruptive. On Twitter and GitHub, we found a lot of developers complaining about the interaction of these bots. Here is one example, another one, and a lot of examples of it. To better understand what is happening, we have collected the interaction problems from the state of the practice. We have manually analyzed pull requests looking for, first, human users mentioning bots, and also bots interactions like bots opening, merging, or comment on pull requests. Here are the three main categories we found. The first one is bots introducing communication noise. In some cases, bots introduce noise to the communication of developers, inflating the pull request with annoying comments that are ignored by maintainers and contributors. The second one is the lack of information about the bot. We found that contributors would like to know more about the role of the bot in the project. And the last one is bots taking wrong actions. In some cases, the rule-based nature of these bots lead them to take wrong actions in certain situations. In order to mitigate the problems we found in this state of the practice, we envision the concept of a MSABot. This MSABot will act as a middleman between human developers and the other bots in a GitHub repository. So, the MSABot will avoid massive information by mediating the action of bots on pull requests and summarizing the feedback of these bots. Moreover, developers will be able to interact with MSABot via comments using natural language. In addition, developers can customize the content of the feedback of the MSABot. And finally, if needed, the MSABot will help developers to deal with the consequences of bots taking wrong actions on pull requests. Now I'm going to show an example of the MSABot interacting on GitHub. So here is a GitHub repository and some modifications that I would like to integrate into the main branch. So I will create a pull request and wait for the bots. This first bot is TrafficalBot, a bot that I previously configured to act on every pull request. Then the MSABot will never block the interaction of this specific bot on pull requests. Now the MSABot called -robot left a comment summarizing the feedback of the other bots, the comment linked, and request info bot. The comment linked found that my comment message did not follow the conventions, and the request bot info request for more information in the pull request description. And now, as I don't remember how to interact directly with the bot that runs tests, I will comment here using natural language, and the MSABot will call the bot for me. So basically, I'm typing -robot, could you please call the test bot for me? Now I need to wait the feedback of the test bot. So the test bot left a comment about the code coverage, and this is basically the workflow of the MSABot -robot. In this work, we found that the interaction of bots on pull requests are bothering developers. Therefore, we present our vision of a MSABot as a centralized way to control the dynamic of the interaction with existing bots in our repository. We believe the MSABot will provide additional value for the human-bot interaction, reducing interruptions and helping developers to stay aware of important information. Thank you so much. For more information about this research or for discussions, please follow me on Twitter or send me an email. Thanks.
Thank you, Marielle. very good presentation. It seems that you have already a job for next year. People are asking for a tutorial on video. So open for questions. I will start with the first one. It seems that your presentation has a connection with the previous one from Chris, because you were discussing some methods, some strategies to improve how the bots interact with the developers. And you are proposing a MSABot. Do you see this connection? How can you change your MSABot to integrate those recommendations?
Let me see. Yeah, I see a connection between our research, but I can't see now how I can use those recommendations. I don't know.
Okay. Talking about other presentations, we discussed a lot of the problems that bots can raise during the interaction with developers. You yourself found a lot of people complaining about bots. So what kind of fixes are you proposing?
What kind of fixes for the problems?
Yeah, for the problems.
Okay, so this is a part of my doctoral research. So in this work, we show the concept of the MSABot, but in my research, we are trying to interview developers, so maintainers, contributors, and bot developers, to understand their perspective of this or such problems. So, but in this work, we found three main problems that are communication noise, lack of information about the bot, and bots taking wrong actions. And this envisioned MSABot will first avoid massive information. So the MSABot will summarize the answer, the response of the other bots in our repository to avoid this noise in the communication. And then the MSABot will also support developers' questions. So a maintainer or a contributor could ask for help, and then the MSABot will respond using natural language. And another point is that the MSABot will provide to maintainers to customize the response. So if on my project, I need more information about the response of the other bots, I can customize the response of the MSABot to fit the needs of my project. And for bots taking wrong actions, the MSABot will help maintainers to deal with these wrong actions. I hope I answered your question.
Yeah, definitely. Any more questions from the audience? Neil has an observation. Neil, go ahead.
My observation was just that since we are moving into asking a lot of developers questions about these things to avoid overwhelming them, we could do something like the Napier survey, which I believe Stefan knows quite well, where, in that set of surveys, each, organization kind of surveys developers in Brazil or developers in Canada or whatever, and you can combine the results to see what, you get a much richer set of data from that.
Okay, awesome. Thank you. Okay. So Ashish has also a question.
Okay.
Yeah, thank you. First of all, thank you for the great video presentation. It was really nice. I myself into doing video editing, and I know it's a lot of post-production work and it goes into that, scripting and everything. So I really like the concept of MSABots, and even I am also working on a pull request-based research, which I'm going to publish next year. So my question related to you is like, the use case that you have shown in the MetaBots, that it can reduce the communication noise by clubbing all the messages together in a one message and giving you a one view to see what other bots have said about your pull request. So my question is it like only MetaBot is only going to club the messages from the bots which I have assigned to this project, or on a GitHub, maybe, I don't know, there is a bot exist for a code coverage or a linting or anything, but I want that bot to run. So can MetaBot recommend me something like that, or can I just search over the listing of all the bots using MetaBot? Have you thought about extending MetaBot feature to this particular aspect?
So far, we are planning to render only the bots that are integrated into the repo. So but it's a great question. We can think more about it and try to include in my research. But so far, we are only considering the bots that the maintainer integrated into the repository.
Okay, I see.
Okay, so let's thank the speaker. Thank you, Marielle.
Thank you.
And let's go to our last presentation of the session. Linda is already here, so let's play the presentation.
Hi, my name is Linda Elenhov. I'm a PhD student at Chalmers University of Technology and the University of Gothenburg in Gothenburg, Sweden. I'm here today to talk about a study that I did together with Francisco, Martin, and Samet. It's called Challenges and Guidelines on Designing Test Cases for Test Bots. So why did we do this study? Well, there's an increased presence of bots in software engineering, particularly bots that support software developers in development-related tasks. So last year at this workshop, I presented a taxonomy where we talked about this as DevBots. And DevBots are a subset of software bots. They're not necessarily chatbots, and they're assisting software developers in development-related tasks such as coding, testing, etc. Since they're often embedded in our development cycles, it's important to understand how we can create them to, for instance, reduce costs in test maintenance, execution, and debugging. We've conducted this investigation in a company in the automotive industry in Sweden that uses test bots to test their software and report the results to engineers. The focus here lies on bot creators and not bot users. So our case company then. They're a company who are a provider of service as a product for several car manufacturers around the world. The bots are used to test components in a microservice architecture. The bots are deployed entities in a deployed microservice environment, and this is where the testing occurs. The company has several different types of test bots, load testing, integration, and system testing, and this study only looks at the end-to-end system testing bots. So for them, execution speed and the communication of relevant test feedback to engineers are important. And we just don't want to decrease the time it takes to run it because we want to give faster feedback, but also because of cost. The company uses AWS Lambdas, which is Amazon's pay-per-use model for serverless applications. And this is what they use to host these test bots. And this is why the design is important, because the design can change the time it takes to run these tests. And in the paper, we call this the effectiveness of the bot. So this is not the same as test effectiveness, which means that the test finds more bugs, but something else. So why are these considered bots and not simply automated test scripts? Well, there's no consensus on the definition of bots. There are existing taxonomies, and you can find these in reference in the paper. Both of these mention the facets autonomy and interactivity. And for these test bots, they're automated and autonomous. So the bot is a built entity that is deployed as its own component in the microservice landscape. It's run continuously and it interacts. So it sends update to dashboard, and in case of fail also communicates this via Slack. And this type of tool is considered to be a bot by practitioners. So I've linked a preprint of an FSC accepted paper where we talk to and surveyed several practitioners about the definitions of a bot. So the research questions of this study is, what are the main challenges when designing and executing system tests on software bots? And to what extent does the test design affect the effectiveness of the test bot? And as I said before, effectiveness of the test bot in this case is the time it takes to run and report the result of one test, not the amount of bugs found. And this is more about how to build the bot than it is about how to make a good test. So we did a case study where we collected direct and indirect data. We did this in 2 ways. First, a semi-structured interview. A set of semi-structured interviews. The participants were selected based on having previous experience with the test bots, which meant that they were familiar with the overall scope of software test bots and had worked on their development. We had 4 participants, 2 senior developers, 1 junior developer, and 1 architect. The interviews were recorded, transcribed, and coded. We performed a thematic analysis on the interview data in order to find patterns in the raw data that later was used as base for the coding. The outcomes were categories which summarized the data. So we expressed key themes and processes related to their usage of the test bots. Our findings were later presented to the participants of the interviews to clarify and validate our understanding of their process. We then did a qualitative assessment of artifacts related to the bots. So analyze data from software artifacts. These artifacts were test bot code, test case code, and requirements for the system under test. And we did this in order to investigate the design of the test bot and their test cases. So the result then. We have 3 major themes, challenges, where we identified problems, test design, which are things independent to language and implementation, and frameworks, which are things related to the implementation. So then we have important sub-themes here. We go back to our research question. The first one was, what are the main challenges when designing and executing system tests on software bots? So when we look at the themes related to research question 1, the answer looks like regular test-related problems. What then changes this is when we look at how these problems affect the implementation specific to bot characteristics, namely autonomy and interactivity. So the first thing related to this is autonomy. This made the modularity important. Test cases that they execute will be in smaller blocks and independent, so that the bot doesn't need to sync with one another on test dependencies. The second one is interactivity, and it's related to the reporting. How it reports the finding is important. So where does it go, and what is a good way of doing it so that we don't, for example, spam the chat? Then we have research question 2. To what extent does the test design affect the effectiveness of the bot? So different design choices affect the effectiveness. The one that had the greatest impact on time was using asynchronous programming. Particularly, this benefits the bot since it enables a parallel and faster execution of tests and diligence when designing context-aware and independent test cases. So it both increases the effectiveness and the autonomy of the bot. So from these themes, we then developed 6 guidelines to aid creators of this type of bots. You can find them all in the paper, and again, it's more about how to build the bot than it is about how to make good tests. So as an example, I can show you one of the guidelines. The first one is, what do we want to do? So we want to use asynchronous programming methods to invoke system endpoints. And why should we do this? Well, according to the data analyzed, asynchronous programming methods allow the test to continue testing independent functions simultaneously and can thus reduce execution time. And how is this done? Well, as an example, with the Java framework Completable Future, tests can be executed with the method supply async. In this case, the framework will run the test asynchronously and return the results from the test without blocking the execution of other tests. So conclusions. We support testbot creators and designers by supplying a list of challenges reported by industry. From that, we created a guideline to support practitioners when creating this type of bot. Future work is to look at commonalities across domains. This is just one domain, the automotive industry. And also, we want to look at other types of bots. Both investigate different types of test bots. Like I mentioned, the company has loading and integration test bots, but also to look at totally different software development bots like deploy bots, etc. That's all. Thank you for your time.
Okay, thank you. So Linda is here, so ready to take questions. And while people formulate their questions, first, congratulations for running a case study in a real setting. I think this is really important to have this real scenario to test those tools. And I was curious about the definitions. I thought that would be brought earlier in the workshop, but now in the last presentations, we talked about definition. And that's something that we often discuss a lot. I know that's part of the other paper, the FSE, but maybe you can give us a glimpse of it, how you define, and mainly what is not a bot that people usually consider a bot.
Well, the thing that we came up with was that there was no one definition of a bot that people could agree upon. So we surveyed we talked to 21 developers. And then we surveyed another 110, I think it was, on the topic of bots. And so we came up with 3 definitions, and they all contain automation and then some type of human-like aspects. So it's either a chat, so a Charlie type bot is what we call it, which is basically anything that is automated, but it has a chat interface. So it communicates with the human in like a Slack or in some other form. The second type is an Alex bot, which is something that we know as the GitHub bots. So it's mainly an autonomous thing that does things without us asking it to do it. So it comments and it gives suggestions and stuff like that in the background, but it doesn't necessarily chat with us. And the third type of bot that we found is like the smart bot, which we call the SAMbot. Which has some type of more intelligence, or what you can call it, behind it. Yeah, so those were the 3 definitions that we used in the FSE paper.
Awesome. Yeah, I bet that a lot of people here would like to read this paper, because that we were discussing a lot. And regarding the evaluation, did you see any challenges or recommendations that are specific for certain types of bots? Because as we were discussing, bots can be of multiple types. So did you see some clusters?
In this study or in the FSE?
Any of those, as we were discussing both.
Well, for this study, I mean, we're looking at a very specific type of bot. So I would say it's an Alex type of bot, and it's an Alex type of bot in a microservice environment. So those were very specific for that type of how to, like the guidelines on how to build it was very specific. But for the other one, since we mainly talk to what developers think about things and how they react to all these things, it's not that much of like the clustering thing, I guess. I'm not sure if that answers your question.
Yeah, it does. Neil?
Yeah, thanks for the presentation. I guess my question, and I have to confess I didn't read the paper in complete detail, is there's criteria for writing good tests, like I think INVEST is one acronym. Is this I guess I'm trying to figure out where the gap lies, because a lot of the guidelines seem like you should do this as a tester anyway.
Yeah, we know some of the guidelines are a bit test specific, but it's a bit like the Jordi Chatbot said in his introduction, that you need to be a polymath in order to create bots and to create like both platforms and stuff.
Right.
So you either need to know everything about creating good tests and about creating good lambdas and creating, yeah, all of these things. And we just took like the most important stuff from all the different things and put them in one place, so that if you want to create a similar bot, then you need to keep these in mind.
Thanks.
Okay, so it seems that we are already moving to the open discussion. Thank you, Linda. And as I observed, we are more mature in terms of a community that is researching bots, because at the beginning, we were just presenting examples like, look, here I developed a bot, or I got this bot and analyzed. And in this workshop, I saw a lot of papers that are actually discussing challenges in designing bots, or how can, for example, a MSABot can solve some of those problems, how the bots interfere in the dynamics of the community. So we are moving away from talking about definitions and examples of bots. So we were trying to understand the landscape to a higher level analysis, like design guidelines, or knowing what works well, what doesn't work well, supported by theory, for example, as presented by Chris. So that's really what was really pleasant to see in this community. And as part of this open discussion, we can ask anything to anyone, but I'd like to hear you about your takeaways. What did you like in the workshop? What have you learned? What you are going to change your research based on what you listened here? So any opinions about that? You can just raise your hand because won't have that much time to type the question. So Neil.
Well, I've learned that there are some people who've really taken to Zoom presentations, and then there's some people who, like me, are sort of doing what we did before, but on Zoom. So I mean, that's a meta comment, but it's quite interesting.
Yeah, but it's related also to this new format of conference. Probably we mimic what we were used to do before, but I think now it's going to change forever how you do presentations and things like that. So another open discussion that we can have is the format of this workshop. Did you like it virtual? Do you need to do you think that we can do a hybrid in next years? What do you think?
Like, I miss having beers with people after the session.
Yeah,
but I also like the idea that there's a YouTube stream that literally anyone can join in on and participate in. The one thing I noticed about this workshop was, I think I prefer Slack for messaging and chat over Zoom's chat, but it adds yet another Slack workspace, so there's disadvantages there too.
Yeah, that's true. We talked about that, how to manage that. We prefer to have everything in a single place. Okay, and Alex?
Well, my primary comment was already made by Neil. I think it's very important that this event was open for everybody. I don't know whether you have an idea how many students have joined us, or how many people have joined us that otherwise would not have been able to do it. In any case, just looking at the number of participants, which now at the end of the day is 46, it looks very impressive. It really looks very impressive.
Yeah, we were quite surprised. We received more than 100 registrations, and during the day, it was around 45 to 65. We don't have this breakdown of students versus professionals, but anyway, we were quite surprised by the interest that it raised. And I think being online helped that a lot. A lot of people could participate that couldn't otherwise.
I think also one thing that we did differently with this workshop is that we had this Eventbrite, whatever you want to call it, meeting, where people could register for free. And I think that enabled some people, because, you know, we were like, if you're part of ICSI, you can register, whatever, but if you're not, we also didn't want to hold you back. And I think that helped. Like, we got some, I mean, I think Ahmed has the final numbers, but it's 50 some people who just registered through Eventbrite. Right, so that's in addition to the 70 some that we got through ICSI. But you know, in ICSI you can select multiple workshops, so you don't know who's actually going to show up.
Yeah, Walid.
Yeah. So first of all, I think I enjoyed a lot the sessions that I have attended, and I think it's great that you have opened it to as many people as possible. But let me play also a little bit the bad guy. Yeah. So I think. I mean, of course, if you have 50 or 60 or 100 participants in this setting, this is not really 60 participants. I mean, what I have observed, I mean, 60 may be observant or stream watchers or, you know, people that are there, but I have observed rather maybe 10 or 15 people that are really participating in that sense. So that's very comparable to what we have in the regular workshop. So, I mean, this brings me maybe to the original question, what you have asked, whether it should be, you know, completely like this or hybrid mode. And so, I mean, I think it's really good to open up, but I assume that the true workshop participation and experience and exchange is still perhaps not that, you know, it's not meant to scale, it's a scale. So I ask myself, what's the difference of participating like this or asking reading the paper, so to say, or watching the video, right?
So is it a problem if many people prefer to watch silently rather than participate? I think you're making a mistake by implying that everybody who didn't say one thing did not profit from this workshop. I think that is not a takeaway that we should take here.
No, I didn't say this. So I didn't say that everybody that didn't say anything didn't profit. That's not the point. But we are saying that we have many participants, and I'm saying that yes, we have many people that attend. I mean, you know, they were there in the session, but in terms of real participation, I still miss a little bit that the true physical participation, which is more or less the 20 people that were interacting in the session, asking questions, 20-25 people, right? But I'm not saying, I mean, that's why I started by saying it's really great that as many people were able to, of course, listen or watch the videos or as possible. This is, of course, good.
I guess this is why I also brought this hybrid idea in the first place. Because I think if possible, I think the combination would be the coolest thing to have. If we have a physical meeting where you have this strong interaction and where we can go for a beer afterwards, but you can also open it up and people who cannot go to Korea, for example, and even in normal times, for some reason, they can still participate somehow, or at least watch the videos and see the discussions, and maybe even chime in via chat or Slack or whatever we have. So I'm not sure. It's probably technically also not very easy, but in my mind, that would be an ideal combination.
I agree. Okay, so maybe one point here that I really enjoy about the virtual meeting is that it's actually recorded. So one problem I would have sometimes is that I'm really focused on the presentation. I want to ask some questions, but it's hard to pick up all the points that were discussed or remember them after the presentation. So by holding it virtually like this, it's all recorded. It will all be available on YouTube, and anyone at any point of time can go back to the presentation or discussion or point of time they want and rewatch the discussion and benefit from it. So that's one of the benefits I feel of recording and holding it virtually.
Okay, any last question or comment about bots or workshop or beer at the end of the workshop?
So one thing I really liked about this model, and this is generally true of all the virtual conferences, I really like that there is a running discussion about the presentations while the discussion is going on. I think this is something I really miss in other I think we should probably do this much more. Like have a, I like the model where there's a video playing of the talk, and while the video is playing, people are already starting to discuss the talk. I think this makes the experience a lot more fun for me.
Yeah, true. I like that too. Sometimes happens a bit on Twitter in other conferences.
Yeah, right. But that's a very or a much more niche kind of thing, I think.
And this is a good way to engage people both physically and virtually, I think. If we have like a channel that all of us are using, it's a really good way to engage, because the main gap that I see is like how to engage people who are not physically here on discussions and whatever, because there will be two different sets of people, the ones here and the ones there, and they will not interact. So maybe having something like that, building up something collaboratively during the sessions. This would be quite exciting.
Yeah, awesome. So yeah, so just to close the workshop, well, first of all, just to announce that we are planning to submit it again to ICSI. These will be our next organizers. So it's basically Stefan, Mark, me, and Marielle will join the team. And Ahmed was promoted to the chair of the steering committee. So congratulations, Ahmed. And we would love to continue to hear your feedback for the upcoming year. We are going to write the proposal, and we are planning to do a really good workshop, because we can see that there is a huge interest in the topic. And thank you all for your participation. Yeah.
Sorry. Also, if you're interested in joining the PC and you're not already in the PC, please also just let us know. We try to bring in new people, of course.
Oh yeah, definitely. This is an open community, so you are really willing to have more people on board to help on the organization or the PC, or at least send your papers to next year event and participate in it again. We loved this experience and we can have it again. So thank you all for your participation. It was really good. I really enjoyed it, and hope to see you in Madrid next year.
Everybody.
Thank you, everyone.
Thank you.
Thanks.